either in plenary session or in the parallel session. This conference, organized by Department of Mathematics of Institut Teknologi 10 November, which has been 6 years ago. And now, this year is the 6th International Conference on Mathematics, Pure, Applied, and Computation. We have at least 150 participants, 60 parallel speakers, and 5 plenary speakers. They can join with us through online and webinar format conference, and they have some of their share their current research either in pure or applied mathematics as well as in computation. I believe this conference gave a lot of benefit to all participants, not only lecturers, but also students. And I see in the conference participants, some of them from practitioners. This conference aims to bring the current research result and to disseminate to other researchers such that be aware there are a lot of progress in the research on mathematics. We will welcome Professor Masaki Kameko first as keynote speaker. Later on, Dr. Malcolm Ringland Anderson and other keynote speaker as well. And in the afternoon time, we will have a parallel session. I believe you are able to join with this conference, and I believe you have a lot of lesson learned and benefit from this conference for the better and future research. I hopefully this conference is enjoyed for all of you, and I should thanks to all of you and enjoy the conference. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Dr. Anda Rinurwati, for the speech. The next speech is to be delivered by the representative of ITS Rector, the Vice Dean of Faculty of Data and Analytics of ITS, Dr. Anda Martlia, to be followed by an opening ceremony. To Dr. Anda Martlia, the time is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Allahumma shalli ala sayyidina Muhammad wa ala alihi sayyidina Muhammad. Amma ba'du. Our honorable keynote speakers, Professor Masaki Kameko from SIT Japan, Dr. Bernardi Prangono from Sheffield Hallam University, UK, Dr. Malcolm Ringland Anderson from University Brunei Darussalam, Dr. Siti Zanaria Satari from University Malaysia Pahang, Dr. Valeriana Lukitasari from ITS, the Honorable Head of Mathematics Department, Associate Professors Dr. Subhan, and all of the participants. Welcome to the 6th Icompac in 2020. I'm Mardia, as Vice Dean of the Faculties of Science and Data Analytics, ITS, representing the rector who could not attend because it coincided with the 122 ITS graduation. I would like to apologize to Mr. Rector for not being able to attend this event in person. I will read Mr. Rector's welcome speech. I would like to convey my sincere congratulations to all of involved parties for this successful organization of the 6th International Conference on Mathematics, Pure, Applied, and Computation, Icompac 2020, which is organized by Department of Mathematics, ITS. This Icompac 2020 is held as part of our 60th Institute anniversary. It is great honor and pleasure for me to welcome and thank to keynote speaker and all invited speaker for the worthy time to share your experience and expertise to all conference participants. I do believe that your participants to this conference is a highlight and a give significant insight to all of us. I expect that your patronage and support towards the advancement of knowledge through this event will contribute the future development of mathematics. As we know that the role of mathematics is a vital in many aspects of life. There are many problems arise in social, business, economic, environment, and many others that could be solved with mathematics. I'm sure that Icompac will be the flagship conference for researchers, students, and professionals in the area of mathematics and its application to disseminate their research and advancement and discoveries to network and exchange ideas in order to solve more problems. Last but not least, I wish all participants have a very interesting and learning experience during the conference. Moreover, I hope that new collaboration among participants could be established to our, so, to our foreign guests. I wish you a memorable meeting in our conference during this pandemic. We welcome you anytime to visit our university, Institut Teknologi 10 November in Surabaya. Professor Dr. Insinyur Muhammad Ashari MM, Rector of the Institut Teknologi 10 November ITS, Surabaya, Indonesia. By saying Bismillahirrahmanirrahim, I officially open the Icompac 2020.
Thank you, Dr. Randa Madlia, for the speech. Before we continue with our keynote speaker presentations, we would like to invite our honorable guests and participants to have a photo session. Please kindly activate your Zoom videos. I would like to remind all honorable guests and participants to turn on your camera so we can start our photo session. Since everyone is ready, I will count to 3 and our committee will take the photos. 1, 2, 3. Moving on to the next slide. 1, 2, 3. Now let's continue to the other slides. 1, 2, 3. And finally, the last slide. 1, 2, 3. Now we have finished our photo session.
Ladies and gentlemen, we will now proceed to the keynote speaker presentations, to be moderated by Dr. Enda Rohmati. To Dr. Enda, the time is yours.
Okay, thank you, Johanna and Samara. Good morning, ladies and gentlemen. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for being here this morning. I would like to introduce myself. I'm Enda Putri, and I will be the moderator of this plenary talk session. This morning, we are pleased to welcome first Professor Masaki Kamiko, our very special guest from Shibaura Institute of Technology, Japan. Next, Dr. Malcolm Anderson, our very special guest from University Brunei Darussalam, our third special guest from Department of Mathematics, 10 November Institute of Technology, Dr. Valeriana Lukitosari, and also we would like to welcome our next special guest, Dr. Denardi Prangono from Sheffield Hallam University, United Kingdom. And our fifth special guest, Dr. Siti Zanaria Satari from University Malaysia, Pahang, Malaysia. This plenary talk will be organized as follows. Firstly, we will have the talks from our special guests, respectively with approximately 30 minutes for each talk. Secondly, question and answer session for 30 minutes. And the questions are delivered first and our keynote speakers will give the response. Now, I would like to introduce our first special speaker, Professor Masaki Kamiko. He obtained his undergraduate and master degree from Kyoto University and PhD from the Johns Hopkins University, USA. Currently, he is a professor in Shibaura Institute of Technology, Japan, in the field of algebraic topology. Today, Professor Masaki Kamiko will share with us about his research entitled Cohomology of Classifying Spaces. Please welcome Professor Masaki Kamiko to the stage. And Professor Kamiko, time is yours.
Okay. Thank you for introduction. I'm Masaki Kameko from Shibaura Institute of Technology. Can you hear me?
Very good.
Yes.
Okay. And I want to check that. How many minutes do I have?
Approximately 30 minutes, Professor.
Approximately 15 minutes.
30 minutes. 30 minutes.
50 minutes. No?
30. 30.
Oh, 30 minutes. Okay, okay.
Yes.
Okay. Now, I want to share my screen. So let me try to do this. Can you see this slide?
Very clear, Professor.
Okay, thank you. So I want to today I want to talk about the my research, but before I talk about my research, I'd like to talk about the what algebraic topology is. That is my area of research. Okay, so roughly speaking, and algebraic topology is a study of topological spaces using algebraic invariants like vector spaces or groups, abelian groups, modules, and so on. And the cohomology is one of those invariants. Okay. And although algebraic topology is classified as a pure mathematics in the past, at least. Okay, it's a branch of pure mathematics, but in today, it has several applications in many areas in mathematics. For example, you may heard of the topological data analysis in statistics. And this is a very recent development, but in material sciences, they use K-theory in algebraic topology to classify certain materials, say topological insulators and so on. So I'm not going to talk about these applications today, but I want to remind you that today the boundary between pure mathematics and applied mathematics are, say, not so clear. Okay, maybe it is not a good idea to separate mathematics into two parts, like pure mathematics and applied mathematics. And I want, although I think I live in the world of pure mathematics, I want to emphasize that today, pure mathematics and applied mathematics are, to some extent, related to each other. Okay. So, and I'm going to talk about the cohomology of classifying spaces. Okay. But before that, I want to talk about the algebraic topology first. So this is my plan of today. Okay. First, I want to explain the idea of algebraic topology and what is that. And I also want to mention briefly that what topological TDA, it is a topological, it is called the topological data analysis. Okay. TDA. And this is the creation in 21st century, I believe. And as this name shows, this deals with this topological data analysis deals with, see, data. Okay. So in a sense, it is related to the data science. And after that, I want to explain what cohomology is and what classifying space is and what D groups are. And after that, I want to mention the open problem. This is nothing but the computation of cohomology of classifying spaces. Okay. And at the end of this talk, I would like to mention what Atiyah-Hirzebruch spectral sequence is. It is the, in my opinion, it is very difficult for me to recognize that Atiyah-Hirzebruch spectral sequence is applicable to material sciences. Okay. But somehow, recently, I found several papers written by those in material sciences on the Atiyah-Hirschfeld spectral sequence. I want to end this talk with this. Anyway, what is the topology, algebraic topology? And first of all, what is the topology? Topology is the study of topological spaces. Okay, so the topological spaces is the central concern for topologists. But algebraic topology uses algebraic invariants to study this topological space. Okay. And what does it? How does it related to data science? I want to explain a little bit. So if we have n-dimensional data, okay, we can construct something called simplicial set. And from this simplicial set, we can construct some algebraic invariants called homology. And it is usually called persistent homology. But anyway, this part is this part is the so-called part of the topological data analysis. And but we can, starting with simplicial set, we can construct a topological space, and also we can construct simplicial sets from topological spaces. Okay, so these are, roughly speaking, these are the same in a sense. And to get the persistent homology, you have to use simplicial sets. Okay. But for topological spaces, we can define other algebraic invariants. Some of them are called generalized cohomology. Some of them are called homotopy groups. And therefore, there is there are arrows from topological spaces to these algebraic invariants. This side is the algebraic invariants. And this part is essentially topological spaces. Topological spaces. And this connection between topological spaces and algebraic invariants, these are the essence of the algebraic topology. So with this respect, okay, in the topological data analysis, this part is provided by the algebraic topology, and this part is a simple construction, and it's not so difficult. But the difficult part is how to compute this persistent homology from simple initial set, and how to interpret the result and go back to data. That is the difficult part. Okay. Anyway, this part is, at least to me, this part is very interesting, and it contains very challenging problems. So let me explain a little bit more on cohomology. Okay. And we usually call it generalized cohomology is a functor from the category of topological spaces and continuous maps to the category of graded abelian groups, say abelian groups. How can we use these things? So let's consider topological spaces like a sphere. This S2 is a two-dimensional sphere. So the picture is something like this. And this side, S1 times S1, this is called the torus. And this is a closed surface, and it looks like this, the surface of the donuts. And for human beings, it is clear that these two are completely different spaces. But how do we prove it? We are mathematicians, so we need to prove that these two are different. Okay. To prove that, we can use algebraic invariants. Okay. And if we compute the cohomology group of this S2, if we look at the one-dimensional cohomology group over integer, then we do have 0 here. And if we compute the cohomology of this S1 times S1, one-dimensional cohomology of this torus, then we do have a direct sum of 2 copies of integers. And it is mathematically, it is very easy to figure out this is different from this. So in short, we can say this part is, to some extent, it is difficult to deal with. And this part is, once we computed these invariants, this part is relatively easy to deal with. So algebraic topology gives us tools to convert difficult problems into easy problems. It's like, say, Laplace transform. Okay. Using the Laplace transform, you can transform a difficult differential equation into a simple algebraic equation. And solve this algebraic equation, you get the solution. And let's move back to the original world by taking the inverse Laplace transform. Then we have a solution. Okay. The situation is similar. Okay. we just start with the topological spaces and move it to the algebraic objects. Also, we can talk about slightly different problem. Okay. I'm not going to explain these spaces right now, but if we take the S3, it is a three-dimensional space. Maybe I should write. This one is defined by x0 squared plus x1 squared is equal to 1. And this one is the quotient space obtained by identifying minus x with x0, x3. And we do have these topological spaces, and we do have a continuous map from S3 to RP3. But sometimes we want to find a cross section. Cross section is a homomorphism like, not homomorphism, a continuous map like this one, satisfying this is the identity map. Again, we can show that there is no such map, no S satisfying this condition by using algebraic invariants. Oh, I made a mistake here. How did I write this? This one is, sorry, this one is the RP3. So by computing the mode 2 cohomology, algebraic invariants of this RP3 and S3, we have Z2 and 0. And if this equality holds, then we should have a sequence like, sequence of homomorphism like this one. This one corresponds to I star S. And composition is the identity map. But it is impossible because this homomorphism is not injective. And we want this to be injective, but here it is not injective, so the composition is not injective. Therefore, there is no such S. Okay. So this is the fundamental use of the algebraic topology. Okay. Once we compute cohomology of some topological spaces, then we can use those to prove many things. And I think I don't have enough time for this example. So let's move on to the classifying space. Okay. And classifying spaces are topological spaces obtained from some discrete, sometimes rather simple data. So for example, if we have a simple shell set, then we can construct a topological space but it is done as follows, something like this. Just taking the this kind of topological space and take the disjoint union and introducing the equivalence relation and take the quotient, we have another topological space, and that is this is called the geometric realization of this simply shell set. Anyway, the point is, if we have a simply shell set, we can construct a topological space. And if we have a topological space, then we can obtain a simply shell set. So essentially, simply shell sets and topological spaces are equivalent to each other. And if we replace this simply shell set by a simply shell set obtained from a group, then we can get a classifying space. And I want to write it BG for a group G. The construction is same to this one. But anyway, the point is, if we have a group, then we can get a topological space. And this topological space reflects certain properties of this original group. Okay, so to study this group G, yeah, we can study this. And what kind of group am I interested in? I'm interested in a Lie group. Okay. Lie group is not only a topological group, but also it has the structure of a manifold. Okay, and let me give some examples. So the one of the most simple Lie group is the circle. It's the complex numbers of the absolute value 1. Sometimes we just call it U1. This is the unitary group of unitary matrices of 1 by 1 unitary matrices. Okay. And similarly, we can talk about the absolute value 1 elements in the quaternion. Okay. Then we do have S3. As a topological space, it is same to the S3, and it is usually, we call it the SP1 or SU2. This is the special unitary group of 2 by 2 matrices. And again, taking the quotient by its center, we do have the SO3. Well, this one. And so there are many Lie groups, but the truth is, if we assume Lie group is simply connected means the the fundamental group is 0. But anyway, if we assume a Lie group is simply connected, then it is known that it is a product of simple Lie groups. And the point is, simple Lie groups are classified already. Okay. Simple groups consist of 2 families. One is called classical groups, like SUN, SPN, and SPN. SPN is the double cover of SON. And these are very important in, say, physics and so on. Also, there are finite number of simple Lie groups called exceptional groups. And somehow they are named E6, E7, E8, F4, G. So there are only 1, 2, 3, 4, 5 exceptional Lie groups. And for these Lie groups, we can construct classifying spaces, BG, like this one. And almost 60 years ago, Armand Borel computed these cohomology groups of these classifying spaces under the assumption that if the integral homology of original G has no P torsion, then here P is the prime number. So, this is the prime number.
Sorry, Professor, I would like to remind that the time is 5 minutes left.
Okay. Yeah, thank you. So, here is, and if P is greater than or equal to 7, this integral homology has no torsion. Okay, and there are only finite number of torsion prime cases. Okay, in other words, the cases did not the cases which are not computed by Armand Borel. Okay, and those are these cases, and most of these cases are already computed. So let me write this way. And so these are the known results, and but still we don't have the answer for these two cases. And that's what I'm interested in and doing mathematical research right now. So I'm not sure if this kind of research has a direct application to the say real life problems. But at the end, let me remind you that Atiyah-Hirtable spectral sequence was, so this is some tool in algebraic topology, and I thought it has no relation with a real world problem, and it was invented to study the classifying space of compact Lie groups in a sense. Okay. But today, we do have some papers written by material scientists on Atiyah-Hirtable spectral sequence like this. So maybe my research on this kind of problem might have some impact on the material sciences. Okay, that's what I wanted to say today. Thank you for listening, and terima kasih banyak.
Thank you, Professor Kameko. Thank you for the great talk. And now we go to our next distinguished speaker, Dr. Malcolm Anderson. I would like to introduce Dr. Malcolm Anderson. He took his first degree in applied math and theoretical physics at the Australian National University in Canberra, then completed a PhD in theoretical astrophysics at the Institute of Astronomy in University of Cambridge. He has taught applied mathematics and mathematical physics at the Australian National University, the University of New South Wales, and Edith Cowan University. Since 2000, he has been a member of the mathematics group at University Brunei Darussalam. His research interest is in the field of mathematical physics, general relativity, cosmology, and resources modeling. In this talk today, Dr. Anderson will share with us about his research entitled Cosmological Perturbation Theory, Please welcome Dr. Malcolm Anderson to the stage. Dr. Anderson, time is yours.
Okay, thank you very much. Greetings from Brunei Darussalam, and thank you very much to the organizers of Icompac 2020 for inviting me to speak at today's conference, in particular to Professor Dieki. Now, I hope I can share my screen with you. I'm not sure how that works. Right. Okay. So yes, I'm going to talk today about cosmological perturbation theory. This is something, again, like the previous speaker's talk, I guess it doesn't have much application to real life. Many people who are watching would probably be unfamiliar with the basic assumptions and the methods that are used. So this is just a summary talk. There'll be very little about my own research in this talk at all. So anyway, the opening picture here is a picture actually of the campus of University of Brunei Darussalam. So as I said, this is essentially where I am, although I'm not in any of those buildings. So the universe is something that we've only been discovering really in the last 100 years using high-powered telescopes and both optical and radio telescopes, and very, very recently now we can observe the universe also using gravitational wave telescopes. But something that we discovered, well, that scientists discovered centuries ago, is that the further out you look, the more homogeneous the universe seems to be. And so if we look right back into the great distances, with the panel on the top left there, which is also corresponds to very, very early times in the universe, it looks almost homogeneous. There are lots of, there are inhomogeneities, and these are important because these actually lead to the formation of structure later on as the universe expands and cools. And of course, we end up with with galaxies, stars, planets, and everything that we know in the world around us, like cities. And all of these things originate in the inhomogeneities, the very small inhomogeneities that we see in the microwave background in the very, very early universe. So the whole point of cosmological theory is to try and explain how this process works, how we go from small inhomogeneities to large-scale structure nowadays, or structure on many different scales nowadays throughout the universe. So,
Dr. Anderson, sorry.
Yes, can you see?
Would you like to share your slide, please?
Sorry, I thought I had. You cannot see?
Not yet.
Because I pressed.
No, we cannot yet.
I can't. I haven't got anything on the screen myself. I can't see you either. Sorry. What's happening? Here it is. Okay. So as I said, I pressed share screen. Does that work? Doesn't seem to make any difference. Press share screen. Do you know how this works, or do I have to press this? Okay, sorry. I've never ever had a Zoom conference before.
Okay.
My apologies.
Thank you.
Go back to the beginning. Sorry. Yes. Anyway, this is the first slide, as I said, which is just a picture of a part of the campus of University of Brunei Darussalam. So, as I said, I'm not in one of those buildings, but that's essentially what the campus looks like. Yeah, and the slide here just illustrated what I was saying about the universe progresses from a very early stage where it's almost homogeneous, as shown by the top left-hand panel, to a point where we've got structure on all different scales, on scale of galaxies, planets, of course, and cities. So how mathematically can we even approach this problem of trying to describe how the universe expands and the inhomogeneities that existed in the very early universe, how they get essentially larger and stronger, and eventually they participate in gravitational collapse to form objects that we're familiar with. So the starting point is just geometry, coordinate geometry, basically, and we're all familiar with the three-dimensional geometry system, or three-dimensional coordinate system that usually has the name of Descartes associated with it. So we just have essentially three coordinates of space. And one of the pioneering insights of Einstein was, in fact, we can extend this kind of geometry to 4 dimensions if we include time. But time is somewhat different from space. You can see from the line element in the middle of the page there, time and space actually have to have different signs in the expression for what is called the line element, ds squared. Ds is actually a quantity which can be positive or negative. Ds squared, this is, can be positive or negative, and it tells us how objects actually how they can move through 4-dimensional space-time. So light waves or photons can only travel with ds squared equals 0, and material particles can only travel with ds squared positive. Okay, and associated with this, there is what's called the chronometric hypothesis, which says that the elapsed time that you experience if you're traveling along any path in this 4-dimensional space is given by the integral of ds. And of course, that only makes sense if ds squared is positive. So if we wanted, that's a description of essentially empty space with no objects and no gravity. If we want to add to that a description of material objects, which, and particularly their gravitational fields, then again, Einstein in 1916 recognized that what we need to do is take that original 4-dimensional space-time line element and generalize it completely. So we turned it into essentially a 4x4 matrix. So in the original formulation there, it just looks like a matrix with elements down the diagonal, 1, -1, -1, -1. And we turned it into a completely general symmetric 4x4 matrix, which is called the metric tensor. And this tells us again how we can calculate ds squared. And again, the same relationships hold. I mean, the same constraints about how objects can move through space-time exist with this more general form of ds squared. And the components of this metric tensor are in general functions of all the 4 space and time coordinates. And so, of course, it becomes an extremely complicated problem to do this. And one thing that is relevant to what I'm about to speak, what I will speak about later on, is the fact that we also use the metric tensor to distinguish between different types of vector fields in space-time. So if we take the inner product of a vector field using the metric tensor GAB, multiplying V by itself and then contracting with GAB, then depending on whether that quantity is positive, negative, or 0, we have a vector which is either time-like, space-like, or null. Now what that means is, again, if it's time-like, it's pointing in the direction of the velocity of some kind of observer, for velocity of some kind of observer in the space-time. And if it's null, it's pointing in the direction of light waves. And space-like vectors do have their uses mathematically, but they don't correspond normally to anything physical. So that's the first ingredient of what's called general relativity nowadays. And the second ingredient is that we actually determine what the elements of this metric tensor G are using what are called the Einstein equations. So the Einstein equations basically tell us how to construct a quantity, a fairly complicated nonlinear functional of the metric tensor, which is called the Einstein tensor in the end, at the bottom there, the GAB. And what we do with that is once we've constructed that, if we're just given any particular metric tensor as a function of the coordinates, we construct the Einstein tensor GAB. As I said, this is a very complicated process in general, and there are software packages that will do most of the calculations for you. And once you've calculated GAB, which again is a 4x4 matrix effectively, you then work out its eigenvalues. And there's an eigenvalue that corresponds to a time-like eigenvector, and that eigenvector is considered to be the velocity of the matter that's moving through space-time, and the corresponding eigenvalue is the energy density rho of matter, which is a very important quantity in cosmology because it's rho that essentially determines where the matter is and how the structure evolves. There are, of course, 3 other eigenvalues of the Einstein tensor. These are called the principal pressures of the matter field. Fortunately, for most applications, we just assume that they are 0. So obviously making some assumption about what these eigenvalues are constrains the metric tensor. But this is a very complicated inverse problem because it's the Einstein tensor is a nonlinear functional, as I said, of the metric tensor. Very, very complicated nonlinear functional. But the simplest possible situation that we can envisage is, which is relevant to cosmology and surprisingly it's actually a very good model of the universe on large scales, is if we assume that the line element of the corresponding spacetime is homogeneous and isotropic, which means that basically the only variation occurs in time. So if you just move around in space, X, Y, Z, you change X, Y, Z, the line element doesn't change. And if you also work out the vectors pointing in various directions, they're always the same no matter which direction you're pointing in, which is important for observation. It means if you look at in any direction in the universe, you'll see the same kind of things. And we know that if we make those assumptions, this is something that was discovered at a general level in the 1930s, then the line element is shown in the first equation at the top of this page here. It's basically what's called a maximally symmetric line element. That on the top line there, that's in spherical coordinates, because there are possibilities which relate to this number k here. K can be 1, -1, or 0, corresponding to different types of universes, which are shown in the picture on the right here, the bottom right there. There's a picture showing the different evolution that occurs for those different values of k. But the only one that's relevant for us nowadays is really k equals 0, because all the observations seem to indicate that k is 0, and we have a flat universe, not an open or closed one, which again is, from the point of view of simplicity, is not very surprising. So if we assume that k is 0, we can remove, or we can go from spherical coordinates to just Cartesian coordinates, and we end up with a very simple line element that's shown at the bottom there. So that looks extremely simple. It's almost the same as the original line element that Einstein came up with in 1905. But the difference is there is a function of time outside the components, the dt squared and the dx squared plus dy squared plus dz squared. And this is really important, because this function of time, which is what's called the scale factor, this increase, it turns out, as we'll see in a minute, it increases with time. And that means the universe is expanding. And this is pretty well unavoidable if we make very simple assumptions of what the matter content of the universe is. The universe must be expanding. And this was an extremely important discovery that was made in the, well, at an observational level in around 1930 by Hubble. And before that, nobody really believed this, although it was a prediction that Einstein made much earlier. So what are the kind of assumptions we can make about the contents of the universe? Well, there are three basic types of universe that we could consider. The first one, what's called the cold matter-dominated universe. That's where we assume that the pressure is 0. As I said, there are three principal eigenvalues of the Einstein tensor. If we assume that they are all 0, then it turns out that the scale factor must scale as t squared, and t, the coordinate t in this problem, is not the actual elapsed time, which I mentioned before, which is big T. So it's really only big T that's important. So if we convert to big T, then it turns out the scale factor goes as t to the 2/3. It's still expanding with time, and the density is falling off as t to the -2. So that's one possibility. In fact, that's until recently, that was thought to be the situation in our universe now, that we were in a cold matter-dominated universe. Pressure is effectively 0 if we just look at the space between stars and so on. The second possibility, which is relevant to a much earlier time in the universe, just after the Big Bang, is a hot radiation-dominated universe. So everything is extremely hot because it's much closer together. And as a result, there's a lot of thermal motion, and this is dominated by radiation in particular. Everything radiates because it's hot, and the radiation has a certain type of relationship between pressure and density, which is that the pressure is 1/3 the density. So if you make that assumption, the scale factor, it turns out, is proportional to t, the little t, or t to the square root of big T. So again, it's expanding, but at a different rate, at a slower rate. And again, the density turns out to fall off as t to the -2. And finally, something which wasn't considered to be a serious option until very recently, until about 20 years ago, is a dark energy dominated universe, where in fact the pressure is negative. It's equal to -ρ, the energy density. And it turns out if that happens, if you make that assumption, it turns out that the scale factor actually increases exponentially with the proper time t, big T that is. And that's what's often called an inflating universe. And it's thought nowadays that this is actually the situation that we're moving into. We're moving from a cold matter-dominated universe to a dark energy-dominated universe. This is very controversial, and I'll talk about this maybe later on. But very quickly, just to orient people, if you're not familiar with the situation that observation has revealed to us about the history of the universe, there was a very early phase of inflation, which I won't be talking about in this lecture at all.
Sorry, Dr. Anderson.
Yes.
Would you like to minimize the participant window so that we can see the slide completely, because some dark area blocked?
No, sorry, how does that work? I move it up there? Is that better?
Yes.
Does it make a difference?
Can it be smaller?
How do I do that? Do you know? Can I just hide it all together? Is that
Yes.
make a difference?
Yeah.
Oh dear. I'm sorry.
Thank you.
I've never used Zoom for a conference, I'm afraid. So yeah, you probably haven't seen the relevant parts on the right-hand side there. So it's not at all clear what you can see, what I can see, whether they are the same or different. Anyway, yes, so that picture there that I had of the three types of universes, you can see an open universe expands fastest and a closed universe actually recollapses, and we're in the middle, the flat universe, well, we believe to be. And yeah, so the important thing that on the last slide you probably didn't see is that I said that the density in both the cold and the hot situation scales as T⁻². So the density is falling down, it's actually decreasing, but the variations in the density are not increasing as decreasing as rapidly, and this leads to the formation of structure. That's the important message that will come up later. So here, this is a picture that I've taken from somebody else, of course, but it illustrates what we believe is the history of the universe. Nobody really understands what happened at the Big Bang, whether there was a singularity or time started at the Big Bang. This is all very speculative, but we believe that in the first roughly 10⁻32 seconds after the Big Bang, there was a period of exponential expansion called inflation, and this is where the perturbations that lead to the formation of structure actually formed as quantum fluctuations. After that, there was a long period of, well, from about 70,000 years of hot radiation-dominated universe. The universe, as I said, kept expanding as we see it. It has to expand if the Einstein equations apply. It got colder and colder and colder, and eventually got to a point where the density fell off, the pressure rather fell off to effectively zero. And that's the situation that, as I said, people believed was true nowadays, but it seems now that after about 1 billion years, it was the dark energy that started dominating, because dark energy has a constant energy density, as we saw on the previous slide. So as the density of matter drops off as T⁻², obviously the dark energy will remain at the same level, and it eventually becomes dominant. So that's what we believe is the current situation. So how can we model the growth of perturbations in any of these scenarios? The standard way of doing this is to add to the metric tensor here perturbations, essentially small contributions to the metric tensor, which are commonly called H, and they appear at all positions in this 4x4 matrix. So there are essentially, in principle, 10 of them, because it's a symmetric matrix. It has 10 different positions that are free. These are assumed to be small in absolute value, much less than 1, and it was one of the insights of Lifshitz in 1946, a Russian theoretician, that we can actually decompose these perturbations into 3 types: scalar, vector, and tensor types. Okay, and so this decomposition here, so the HTT term is purely scalar. The vector term here, the HTB term, which mixes dt and dx, that can be decomposed into scalar and vector terms. So this decomposition is not in physical space; it's in Fourier space, effectively. So we have a part that's parallel to the Fourier vector k, which we call zeta, and then there's a part which is orthogonal, which has 2 components, which we call lambda, and a similar decomposition works for the remaining parts here. This is a 3x3 matrix, HBC, and again it has 2 scalar components and a vector and a tensor component here. And the tensor component, because it has various restrictions on it, it's orthogonal essentially in both directions to the Fourier vector k, and it also is trace free, and so it turns out it only has 2 independent components, and these turn out to be two polarizations of gravitational waves. Anyway, so that just to indicate that this is how the procedure works. Of course, you don't have time to understand it in any detail. If you plug this decomposition in, it turns out that the density and the principal pressures depend only on the scalar contributions, but you get these fairly complicated looking expressions like this. And of course, we want to ultimately, again, put things like delta P, delta sum of the principal pressures to 0 if we're in a cold universe, and do other things if we're in another type of universe. So these equations look complicated. They can be simplified if we make a choice of gauge, which I want to talk about on the next slide. This is something, don't worry too much if you don't understand this, but basically this is a procedure by which we can reduce the 10 degrees of freedom to 6, because essentially we don't have any objective way of choosing the time coordinate in the physical universe. And when we do that, when we actually do that, we're essentially mapping the physical universe to the original homogeneous isotropic FLRW universe. And there are many different ways of doing this. And each of these corresponds to what's called a gauge. And if we do this properly, we usually specify gauges according to the physical properties of the identification. So we either say that the density in the physical spacetime is the same as the density in the corresponding FLRW spacetime, or something like that. And as I said, if you do this properly, you can reduce the 10 degrees of freedom we had in the previously to 6. So that means we get rid of one of the scalar and one of the vector perturbations. Sorry, 2 of the scalar and 1 of the vector perturbations. And so there are lots of gauge choices. This makes the whole area very complicated because people tend to work in different gauges. It's difficult to compare the results in different gauges, and it's also difficult to know whether the results are gauge independent, which is very important. But these are 3 commonly used gauges: what's called the Poisson gauge, what's called the Newtonian gauge if you throw away the vector and tensor perturbations, but more generally it's called the Poisson gauge. And this is fixed by a physical requirement, which is somewhat complicated. You have to calculate what's called the gravitomagnetic field and then essentially put it to 0. It's something that is different depending on which observer is making the measurement of the field. But if we choose observers that are what are called co-moving with the coordinates, that essentially means that their velocity is, or their essentially the x component, the x components, the x, y, z components are fixed as they move. This is called a co-moving observer. Then if that observer measures 0 gravitomagnetic field, we end up with this kind of line element. And there are similar things you can say about the other 2 fairly commonly used gauges, the synchronous gauge and the constant density gauge. So in the constant density gauge, the density doesn't actually change, which sounds strange. It doesn't change from what it is in the original homogeneous isotropic universe that we started with. This seems very odd, and it seems that this would make it impossible to have density perturbations, but that's not true, because delta rho is not actually a gauge independent quantity. It's not what actually really measures changes in density, as we'll see later. Anyway, so the Poisson gauge, in my opinion, is the easiest to use. And anyway, if you do that, if you choose the Poisson gauge, you then make assumptions about the pressure content of the universe, in particular that it's adiabatic, which means that the principal pressures remain degenerate. That is, they all have the same value. So we have a degenerate set of 3 eigenvalues. And also that the relationship between delta p and delta rho is the same as the relationship between p prime, that's the dp dt, and d rho dt in the original FLRW universe. This is what's called the adiabatic assumption, and it's thought to be very good. If we do that, then one of the scalar modes drops out automatically, and we end up with 3 relatively simple equations now for the evolution of the 3 different types of modes. The tensor modes has this equation, which describes the propagation of gravitational waves through the universe. I won't be talking about that in any more detail, but this is essentially the basis behind gravitational wave astronomy, this first equation. The second one, the vector modes, is a very easy equation for the vector modes, which we can solve straight away, no matter what kind of background we have. And it turns out that the vector perturbation always falls off as a to the minus 2. This is the scale factor a, which is always getting bigger, and therefore vector modes decay quickly, and nobody takes them seriously. Nobody thinks that they have any physical consequences in the real universe. And so we're left with this more complicated equation for the scalar modes. There's only one scalar function left, that's phi, and this is what determines everything else. This is what determines the formation of structure in the universe, and it's much, much harder to deal with. So as I mentioned earlier, the fluctuations in the metric tensor, which if we concentrate only on the scalar modes, is just the function phi. These are caused, or believed to have been caused, by quantum fluctuations during inflation, which were then exponentially amplified. And since then, they have been evolving according to this equation that that's written here on the previous slide. And of course, the functions a and omega are just functions that of time that are fixed by the background spacetime, the original FLRW spacetime. And so what we do then is we basically model the scalar mode phi as a stochastic function. So we Fourier decompose it, as shown in the first red equation on this slide. We Fourier decompose it, and the Fourier components are basically treated as random variables, stochastic variables, with the average value of phi by itself being 0, and the average value of phi squared effectively being proportional to another function, big phi, capital Phi here, which is called the spectral power function. So as I mentioned a few slides ago, of course, the quantity delta rho is not gauge invariant, and really in the end, anything that you say about the universe has to be expressed in terms of gauge invariant scalar quantities. These are the only things that are measurable and the only things that are the same no matter what gauge we choose. And this is a very complicated issue that is still causes an enormous amount of problems in this area nowadays. Actually showing that a certain function is gauge invariant is quite difficult. But anyway, delta rho is not gauge invariant because we know that we can choose a gauge where it's 0, obviously, and that makes very little sense. So the gauge invariant quantity that we should be using is what I'm calling delta rho ms here, which is essentially the variance of rho, which is not the same as delta rho, it turns out. And we form from that another important quantity, the fractional root mean square density perturbation, which is proportional to the square root, or the square root of the expectation value of the square of the Laplacian of phi. Okay, and that determines pretty much everything. That tells us how the density perturbations evolve. That is a measure of the density perturbations. And if we plug all of this back into the original equations, it turns out that in the hot radiation dominated era, which was the earlier era, the phi falls off as t to the minus 1, and the ratio delta here is the ratio of delta RMS over the original density, the unperturbed density, that remains constant. And that means that structure doesn't form because initially delta is very, very small, and it stays small all the way through the radiation dominated era. So no structure forms during the radiation dominated era. We can understand this actually physically by the fact that the radiation washes away any growth of perturbations, essentially. Everything moves away at the speed of light, and the perturbations can't grow. But in the more recent era, the cold matter dominated era, it turns out that phi, this metric perturbation, is constant if we solve the roughly constant anyway, if we solve the equations. And the density perturbation delta grows as t, capital T. They grow linearly with time. And so eventually, of course, delta, even though it's very small, as the universe grows over billions of years, as it evolves over billions of years, eventually delta becomes equal to 1, although this is a condition that occurs at different times for different wave numbers k. And when that happens, the linear approximation breaks down, and we have gravitational collapse and structure forms. So,
Dr. Anderson, sorry, I would like to remind you that the time is 3 minutes left.
Oh, only 3 minutes left. Okay, sorry about that. Okay, yeah, so, well, I'll skip this slide. Nothing, sorry, what's happened? Yeah, skip this slide. So there are ways of going from the linear evolution to the nonlinear evolution. This involves instead of analytic solutions or approximate analytic solutions to the equations, this involves typically Monte Carlo methods, which is to say you take simulations and over again, and you construct statistics from them. And you can see from this picture here what happens. Effectively, nonlinear evolution just shifts power from low wave numbers, which is to say long scales, large wavelengths, to shorter wavelengths. And that's what we mean by structure formation. And when this happens, objects basically collapse to form stars and galaxies. Yeah, so that's the basic idea behind it. I just wanted to mention one application of this right at the end here. So there are only 2 slides left. Effectively, so what's called the UV scaling catastrophe. This is a big unsolved problem in the area at the moment. So even we make all these assumptions that I've been talking about, and we make some assumptions about inflation as well, which causes the initial conditions for the power spectrum function capital Phi. It turns out that unfortunately these delta diverges. So how can we fix this. There are all sorts of suggestions about how we can fix the divergence of delta, which relates to dark energy or inflation. However, I should just mention that there are other possibilities that if we actually take this seriously, the divergence, and we use it to bias our observations, it turns out that we can actually make predictions about observed quantities which correspond to what we actually see in the absence of dark energy. So this is, again, a very controversial, highly speculative addition at the end here. So the last two slides, or at least this last slide here, is highly speculative. It's based on work by a guy called Skarka in 2017. So don't take that necessarily very seriously, but everything else up to this slide is standard. And basically that's it. So as I said, I don't expect people to have followed all of that in any detail, but it just gives you some flavor of the way that cosmological perturbation theory works. And I do apologize for all the technical glitches at the beginning, but I hope everybody got something out of that talk. And of course, there are lots of pictures that I've stolen from the internet, which I've got credits for. Anyway, that's the end. So how do I stop the share? I think, is that how it works? Okay, yes.
Yes. Thank you, Dr. Anderson, for the great talk. Thank you very much.
My pleasure.
And now we will have the third speaker. Now I would like to introduce our third distinguished speaker, Dr. Valeriana Luki. Sorry. I would like to introduce our next distinguished speaker, Dr. Valeriana Lukitosari. Yeah. She obtained her undergrad study in mathematics of ITS, and she took her master degree and PhD in industrial engineering also in ITS. And her research interest is in the area of optimization and operation research, and several research experiences such as spare part inventory, product life cycle product, and growing product supplies. Currently, she is a lecturer and researcher in Department of Mathematics of ITS, and she is a member of Mathematics of Industry and Finance Laboratory and Department of Mathematics ITS. Today, Dr. Valeriana will share her research with us, and the talk entitled "The Role of Inventories Data for Staying Productive, an Operation Research Perspective." Please welcome Dr. Valeriana to the stage. Dr. Valeriana, time is yours.
Thank you, Ibu Moderator, Bu Enda. Okay, my voice is clearly?
Very clear.
Okay, I will share. Okay. You can also see my slide.
Yes.
Okay, thank you. Okay, Assalamualaikum
Would you please
warahmatullahi wabarakatuh.
slideshow? Sorry, Ibu Dr. Valeriana, would you like to do a slideshow for the slides?
Okay.
Thank you.
Okay. Okay, good morning, good afternoon, everyone. First of all, I would like to say thank you very much indeed to ITS, who's today to represent by Vice Dean Ibu Dr. Madria and Head of Mathematics, Bapak Subhan, PhD, and Conference Chair, Ibu Dr. Rinurwati, and I would like you for the opportunity to invite me as a keynote speaker in this conference, and also of course as well as a speaker, as well as a participant, also would wanted to thank you committee to invite me to share about the role inventory data for staying productive and operation research perspective. Okay, I will share about our research and also my experience in inventory data management in the context of an operation research perspective. Okay, this is the agenda of today's talk. First, I will start with some introduction about what are the inventory and what the nature of inventory, certain and uncertain factor, and how the inventory data implies the business model. And then I will talk about some experiences in research and industrial project and some practical implication. Before I have a multiple academic background, mathematics and industrial engineering, and now I'm active as a lecturer in mathematics ITS. Second content, spare part inventories, and then the third, the determination of inventory to the mean residual life, and then the last, I will share about quality improvement for sustainability. And the nature of inventory data, I have a certain and uncertain data. The nature, we have a deterministic and stochastic inventory data, represent total cost and ordering cost, and then benefit of inventory management to show the relationship between the variable. And that one, the nature of inventory, we have a certain and uncertain factor, and then a stochastic, or we call uncertain factor, probabilistic inventory model, classified into the single and multi-period. And the single model item we are received in the beginning of the period, so during the same period, unsold the item carry out the origin purchase price, and then the revenue generated by unsold item is called the sales value. And then the following are some product for which single period model we appropriate. And then we have a perishable also in this topic. And then seasonal product such as patching, sweet, winter coat, and etc. Newspaper and magazine. And in the single period model, there remain only one question to answer: how much to order. In a multi-period model, order place a regular interval, once week, once month, etc. Then there is only one question to answer: how much to order. However, we discuss Q and R and is one and uncertain demand. However, in inventory management, we have stock or reverse create to carry out the normal activity of company. Proper timely determination of the optimal inventory control strategy allow the freeing significant amount of asset frozen in the form of stock, which ultimately increasing the efficiency of resource use. Even though there are literally million different type of product manufacture in our society, there are only two fundamental decisions that one has to make when controlling inventory. This one, the first one, how large should an inventory replacement order be? And the second, when should an inventory replenishment order be placed? The objective inventory data often reduce the problem if it is more profitable to do quickly but more expensive, or slower but cheaper. Such strategy will be optimal inventory control, which minimize the some milestone costs associated with the production, storage, inventory, sorted per unit of time for a specific amount of time. The management model differ in nature of available information on properties of the simulated system. When the value of model parameter is well defined, nature or corresponding mathematical model is deterministic. If the parameter of the system random variable, random value with a known probability, distribution model as stochastic or probabilistic. If all the model parameters do not change over time, it's called static. Otherwise, dynamic static model are used when receiving one-time decision about the level, reverse level for certain period, or dynamic in the case sequential decision making about the stock level or adjust earlier decision. Taking into account the change taking place, and when the static pattern of change in the system parameter cannot be installed, it is necessary to solve the problem of inventory management in face of uncertainty. Okay, the demand is unknown. The demand is known. The demand characteristics such as mean, standard deviation, and the distribution may be known. In the model inventory, following characteristics are taken into the single multiple item dimension. Consider whether a single item can be used in isolation for calculation, or whether multiple interdependent products should be taken into account as a result of collective budget or space constraint, coordinate, control, substitutability between items. And we have a type of demand classification, that one stationary distribution with a no parameter, and this type of demand follow the probability distribution that is no or estimate from historical data. Commonly used distribution include normal, gamma, Poisson, and non-stationary probabilistic demand. This type of demand behave like a random walk involved over time with regular change on its direction of rate growth of decline. On the basis of demand source, demand are divided into independent and dependent. Independent demand is the demand that consists of individual consumer demand. It's them feeling the need independently of the other. Dependent demand occur when a manufacturer uses a number of components for manufacture of finished goods, and the demand of each component is associated with other and depend on production plan of manufacturer. Nature of supply process, we have a nature of supply process refer any restriction that have been imposed on the inbound process in the supply chain. We have a minimum or maximum order size or replacement lead time. Example, a typical factor considered in this dimension. Okay. Inventory data management relates to logistic activity, quality, storage, resale, or even spare part in the production machine. And the second, We have a spare part inventory. Spare part inventory are not intermediate or final product to be sold to the customer, and the policy that govern spare part inventory are different from those which govern VIP, waiting in process, and other inventory. And then spare part inventory differ from other manufacturing inventory in several ways. First, in the production flow, this irregularity can be caused by change in product mix, equipment breakdown, differences in production rate between different process, material handling, and many other things. Finished good inventory exists to provide a source of product for delivery to customer, are designed to protect against irregularities in the lead time demand. Differences in the quality level, differences in machine production rate, labor trouble, scheduling problem, differences between capacity and demand, and the other well-known and production characteristic. The function of spare part inventory, however, is to assist maintenance staff in keeping equipment in operation condition. Spare parts are not intermediate or final product to be sold to a customer. Second, the policy that govern spare part inventory are different from those which govern VIP, waiting in process and final product inventory. VIP and final product inventory can be increased or decreased by changing production rate and schedule, improving quality, reducing lead time, and etc. And then we have a spare part inventory level, however, are largely a function of how equipment is caused and how it's maintained. Maintenance which require a given kind of part can sometimes be postponed or avoided, and the choice of maintenance action can have immediately impact upon relevant spare part inventory. If condition monitoring indicate a part wearing out, another policy may be to reduce the usage of the part. Few such as option available planning for VIP and finished product inventory. This and other unusual aspect of inventory have authors existing literature in order to see has been done and have unique aspect of maintenance inventory for a spare part, for the spare part inventory. To develop a complete description of spare part inventory, the condition that make them different from waiting in process or finished product inventory need to be described more detail. This condition as follow. The first, we have a maintenance policy rather than customer usage. This one, dictate to need to spare part inventory. For example, one way to restore the functionality of a machine that has a broken part, it is to repair the part, or the part can be replaced. Then decision whether to repair or replace has profound implication on maintenance inventory level. Another decision is the choice of amount of redundant equipment to design into a machine. If there is many redundant parts, it may be possible to replace all non-working parts is a convenient time. And to keep a few units in hand for emergencies, if there is a little redundancy, there's a greater need to immediately available spare part. The second, we have reliability. Sorry. Yeah, reliability information is generally not available to the degree needed for the prediction of failure time, particularly in case of new equipment. One of benefit of continuous equipment monitoring is to enable an operator to predict when a unit will need repair or replacement. But the expensive of such monitoring equipment such that not all equipment can have it installed. And then we have failure, number 3. Part failure are often dependent. This create a problem, particularly if the dependence relation is not known. And then the fourth, we have a cost associated with risk. The cost is being out of the part generally include the quality as well as loss production. There's a cost difficult to quantify. Increased risk to personnel may also be a factor, and costs associated with such risk are not easy to calculate. Components of equipment are more likely to be stocked than complete unit. It is major unit of equipment is expensive, and repair may be preferred to replacement if it is possible. And then we have number 4, obsolescence may be a problem as a machine for which the spare parts were designed become obsolete and are replaced. It is difficult to determine how many units of part for an obsolete machine to stock. And it may be difficult to replace part that no one still keep on stock. And then we have number 6. Demand for part is sometimes may be made through cannibalism or other part or unit. Okay, and then we have a special application. The first spare part inventory strategy with relying on reliability, and the second we will talk inventory control material that the priority quality. And yeah, we have a spare part inventory strategy with relying on reliability. The model introduce figure representation, include the key aspects such maintenance, and we have a maintenance cost, spare part inventory, emergency procedure, and then we are developed for multiple systems, and we refer to vital component and as a critical. The focus in reliability optimization and spare part inventory model is on a critical component. And the reliability optimization, the reliability of system is defined as a probability that the system will perform its indeed a function for a predetermined mission period under a given set of environmental conditions. The main determination system reliability are reliability of its part. It is a structure like a simple series, simple parallel, series parallel, parallel series, and etc. In general, during the design, for its component that will constitute the system, there exists a set of options with a different reliability level such that the unit cost or price, this option increase the reliability level. That is an option less costly than a more reliable option. The main goal of the research is develop quantitative model and method for the optimal reliability decision for advanced for inventory capital good capital. Yeah, as I we study a reliability optimization problem for the situation in which repair by replacement is used, which mean the spare part inventory is a key factor affecting availability, exploitation, pass, cost of inventory. An important aspect the stream research that the costs are limited to acquisition or design and production costs. And then we have a joint optimization of reliability and the spare part inventory. We have therein developed a model for the reliability optimization problem, which include the following attribute: maintenance cost, downtime cost or availability, and then spare part inventory, and the emergency procedure. Such as a reliability optimization problem can be a single state problem or a multi-state problem. While studying a multi-state problem, once its relation to relevant single state problem can explicitly be established. One can analyze and solve the single state problem and use this finding to analyze and solve a multi-state problem. And then we have a developed model for redundancy allocation of inventory in the design. This model includes policy of state, policy of state. This formulation can be summarized as minimize as an objective function and general number system under defined downtime constraint and cost, including spare part cost, repair cost, and then we explicitly relate the redundancy level and spare part inventory level of each subsystem to the cost and downtime subsystem. This one D is mean downtime, this one R repair, and that one cost. This S it's been sorted, and we develop also a multi-state problem into the single state problem by using a Lagrangian relaxation model, relaxation method. The multi-state problem has a combinatorial nature as any of three policy. We have this one 0, 0, 0, 1, 1, 0. This we call combinatorial policy. And
sorry, Dr. Valeriana, I would like to remind you that the time is 3 minutes left. Thank you.
Thank you, Linda. And we compare the policy at the state level, provide a condition under which whereas policy outperform the other. Okay, have reliability, system reliability optimization, redundancy allocation problem. The redundancy allocation problem has been studied in great detail, and efficient means to select sound design configuration. And the design new product involves the specification of performance requirement, the selection of component, and to perform clearly defined function and determine of the system level architecture. And the number second, detailed engineering specification receive a minimum level reliability, maximum weight, maximum volume, and so on. This one configuration, the design of component for the machine, and then We determine of inventory mean residual life. Mean residual life is the length of time the component able to operate until it's failed to operate. When the remaining life is length of time the component can be operated after the certain time. If the system or component operate continuously, it will decrease the level reliability according to the function of time. This is related with maintenance strategy and inventory decision making. And then we have reliability. We have state by state for this research. We have a determination distribution according to distribution identification, distribution suitable test, and then determination of distribution parameter value, determination reliability value, and determination remaining life of part. And then we have a quality improvement for sustainability. One, we have a quality control, make fast. High competitive in era globalization is encouraging companies to make many innovation in their product to suit customer demand and be able to compete with other company. One of which improving product quality. Okay, we have a case study for the research. We have a bicycle frame and component failure. The component that make up a bicycle have a useful service life. Bicycle frame, fork, handlebar, and wheel, brake, and other parts may fail due to design or manufacturing defect, overloading or simple wear or over life a bicycle. Design factors such as function like weight, durability, and cost dictate the material used for component. All those considerations can play the role, the likelihood, nature of component failure. And then we have a critical nature of the control surface component. The frame of fork of a bicycle are at most obvious and visible part of the structure, but the point that the radio interaction with the control movement and are also very important to safety. The control speed and the direction radar interact with the handlebar, brake lever, bicycle seat, and pedal. This component with the rider's body, thoughts, and even a failure to one or more these parts, rider no longer has a full control of the speed and direction of the bicycle. And we have a component failure in the bicycle, frame failure, fork failure, pedal failure, and handlebar stick failure, and seat or seat post failure, and brake failure. And then we have a bicycle manufacturer. When investigating a case involving a claim of improper assembly, it is important to check the following: how long was bicycle ridden between the time of purchase and the accident? Did bicycle buyer consult and the employer about the bicycle time of purchase, and so on. Interesting fact about the market, average selling about bicycle selling, yeah. And then the last forensic bicycle investigation. Among our bicycle experts, you will find the professional who work some most recognized bicycle brand in the world. And then we have a common issue in the bicycle assembly about training, education, experience, basis which the legal industry is established and expert. This concept grounded logic and applicable all industry, including bicycle assembly. Okay, we analyze the need of product quality, identifying ways the effect product quality which occur in the bicycle production process, evaluate the performance of the production process, and develop a quality improvement concept. We have it is necessary continuously estimate and evaluate some of the improvement solution provided in order sustain a success rate repair solution overcoming existing problem. Okay, this is just general model or just overview my research journey. Thank you.
Okay, thank you, Dr. Valeriana, for the beautiful talk. Now we go to the next session. And yes, our next distinguished speaker, Dr. Bernardi Prangono. He is a senior lecturer at the Department of Engineering and Mathematics, Sheffield Hallam University. Dr. Prangono received his Bachelor of Engineering degree in Electronics and Telecommunication Engineering from Waseda University, Japan. He obtained Master of Digital Communication from Monash University, Australia, and a PhD degree in Electronic and Electrical Engineering from the University of Leeds, UK. He has previously held position at the Glasgow Caledonian University, Queen's University Belfast, and the University of Leeds. He also held industrial position at Oracle, PricewaterhouseCoopers, Accenture, and Telstra. His current research interests include cybersecurity, Internet of Things, cloud computing, and green ICT. Dr. Prangono has served as Vice Chair and Technical Program Committee member in numerous international conferences such as IEEE. He also serves as referee for some journals and conferences such as IEEE and also Springer and MDPI. Today, Dr. Bernardi Prangono will share with us about his research entitled Cybersecurity, Data Science, and Machine Learning. Please welcome Dr. Bernardi Prangono to the Zoom stage. Dr. Prangono, time is yours.
Thank you for your introduction. Okay, I'm going to, can you hear me clearly? Yes.
Yes, sure. It is clear.
Okay, so I'll share my screen. Okay, good morning. It's very early morning here in the UK actually. So my topic today is about cybersecurity, data science, and machine learning. So it's so I'm Bernardi Prangono. I'm currently working at the Department of Engineering and Mathematics, Sheffield Hallam University. So, So, yes, the outline of my talk today is about cybersecurity is and talking about data science and also machine learning. it's basically just a but introduction to topic in cybersecurity and data science and machine learning. Hang on, so I will. Right. Yep. Okay. So when we talk about the cybersecurity, so it's basically cybersecurity is kind of set of technologies and processes designed to protect computers, networks, program and data from attack, damage, or unauthorized access. So currently, cybersecurity is undergoing massive shift in technology and also in its operations in the context of computing. And data science and also artificial intelligence are behind this massive paradigm shift. So where the data science is driving the change, the machine learning as part of the AI also play a vital role to discover the insight from the data. So machine learning can significantly change the cybersecurity landscape, and data science is leading a new scientific paradigm. So we probably realize that in today's cyber attacks has becoming more frequent and more complex and more harder to defend. So it's increased, change the landscape in quantity and quality. So for example, we see denial of service attack, or DOS, or distributed denial of service attack, or DDoS attack, social engineering or phishing engineering, malware, ransomware, advanced persistent threat cyber attacks have become like day-to-day news that we can read almost every day. So and the number of data that human generated is increasing significantly. So for example, in 2012, there are 2.5 billion gigabytes of data generated daily. And then it is expected in by 2020, end of 2020. So the number of the human generated is about 1.7 billion of new information per second. So it is really, really a big increase. So, and when we look at the specifically on the fact on the cybersecurity, or the cybercrime, as we know with Sun Tzu, actually we have to know the enemy. So, and then when we say the facts about the in cybersecurity landscape, so cybercrime, for example, is about 6 trillion US dollar in 2021. It's increased from 3 trillion in 2015. And customer fraud and scams also about 1.9 billion. And this 90% about cyber attacks. are caused by phishing attacks. So it's type of one of social engineering. And this we also have like 14 million new phishing sites per month. And this like many attacks basically can be prevented by education and user awareness, like 70% security awareness training, they can reduce the risk threats by 70%. So in like DDoS attack over time, like from 2003 until 2020. So in 2003, we have less than 100 gigabyte per second of DDoS attack. But it is in 2020, it's about 1,200 gigabit per second attack. So the typical DOS attack is especially very hard to defend as a cybersecurity professional. And the main problem with DDoS attack is it's also very easy to do actually. So there are many hackers, like black hat hackers. They have gathered the DDoS attack using like a botnet from thousand or millions Internet of Things devices, and then generate the DDoS attack for a specific target. And malware or malicious software is basically any software intentionally designed to cause damage to computer, server, client, or computer network. So the malware numbers is also increased significantly. In 2015, it's about 470 million malware detected. In May 2019, we have about double, about 900 million malware. So, and one of the most popular malware or is ransomware, which is malware that threatens to publish the victim's data or block access to it unless a ransom is paid. Like in the UK, they have the WannaCry ransomware that we crippled the National Health Service in 2017. So this on the graph here, so we can see that the global ransomware damage costs will reach about 20 billion by 2021, which is 57 times more than it was in 2015. So, and in terms of this COVID-19 related threats, so we can see in quarter 1, 2020, a lot of issues with cybersecurity issues related with this COVID threat. So all from all this data, we should now understand that how big is the cyber attacks growth in recent years, especially this year. So, and traditional methods and techniques to prevent cyber attacks is no longer adequate. So how we can cope with all the cyber attacks? So one of the methods that cybersecurity professional and researcher, they use data science. So we know data science is kind of accumulation or actually interdisciplinary fields of mathematics and statistics, and also have like computer science and also the domain expertise. So basically, data science is a concept of to bring together ideas, data examination. So, and machine learning is one part of data science, which is machine learning also use a lot of data science and a lot of applied mathematics. So as a cybersecurity professional, as research in cybersecurity domain, so we implement a lot of data science and also machine learning, with involving a lot of mathematics and statistics methods. So this data science basically is all about understanding of data. So we use like the dives at the granular level of data. So it involves studying, processing, and extracting valuable insight from a set of information. So nowadays, many researchers use the term data science to describe interdisciplinary field of data collection, pre-processing, inferring, or making a decision by analyzing the data. So by using data science techniques, so security analysts, they can manipulate and analyze security data more effectively, efficiently, uncovering valuable insight from data. So this data science methodologies, including use different machine learning methods, can be utilized in the context of cybersecurity in terms of problem understanding, gathering security data from diverse sources, preparing data to feed into the model, data-driven model building and updating for providing smart security services. So, and people starting to apply machine learning in cybersecurity to prevent cyber attacks, to give the, to cope with the overwhelming cyber attacks that we have seen recently. So this machine learning model typically comprise of set of rules, methods, or complex transfer function that can be applied to find interesting data patterns or to recognize or predict behavior, which could play an important role in the area of cybersecurity. So in machine learning and cybersecurity, so extracting security incident patterns or insight from cybersecurity data and also building corresponding data-driven model is the key to make a security system automated and intelligent, because of the number, the quantity and quality of the cyber attacks or cybersecurity incidents that we've seen. So by using machine learning, we hope that can make security system more effective with more and more effective and more intelligent. So it is becoming essential that we have ability to analyze a massive amount of relevant cybersecurity data generated from different sources, such as network and system sources, and to discover insight or proper security policies with minimal human intervention in an automated manner. So data science in cybersecurity is very important because security is all about data. So when we seek to detect cyber threats, normally cybersecurity professional be analyzing the security data in form of files, a lot of files, and logs, millions of logs from different sources, network packets, or other relevant sources. So traditionally, security professionals did not use data science techniques to make detection based on this data source. So instead, they use file hashes or using custom written rules like signatures or manually defined heuristic. Although these techniques have their own merits in several cases, but it needs too much manual work to keep up with the changing cyber threat landscapes. So on the contrary, so with data science can make a massive shift in technology and its operation, where machine learning algorithm they can be used or implement, exploit to learn or extract insight of the security incident patterns from the training data for their detection and prevention. For instance, to detect malware or suspicious trends, or to extract policy rules. So this machine learning techniques can be used. So it is not just about the collection of machine learning algorithms. So in cybersecurity data science, there is what is kind of new field, which is incorporate the methods and techniques of data science and machine learning, as well as the behavioral analytics of various security incidents. So in CDS, we'll collect a large amount of security event data from different sources and analyze it using machine learning for detecting security risks on attacks, either through the discovery of useful insight or the latest data-driven patterns. So it's not just about a collection of machine learning algorithm, but rather a process that can help security professional or analysts to scale and automate their security activities in smart way and in timely manner. So machine learning is typically considered as machine learning and deep learning are surely going places, and it seems that they are hardly going to become irrelevant in some time to come. So machine learning models machine learning will deals with a bunch of algorithms derived from the by the data scientists to be applied on specific set of data. And there are classic algorithm and statistical measures that can be used as primary tools to develop more complex algorithms. So in cybersecurity, so basically we implement like the three different machine learnings, like supervised learning, unsupervised learning, reinforcement learning. So researcher trying all these different machine learning algorithm in machine learning types in all cybersecurity. So for example, like in supervised learning is performed when specific targets are defined to reach from a certain set of inputs, for example, like a task-driven approach. So in the area of machine learning, the most popular supervised learning techniques is classification and regression methods. So these techniques are popular to classify or predict the future for a particular security problem. For instance, to predict denial of service when the traffic coming, so they can basically use this classification or regression methods to classify is this traffic can be categorized as DOS attack or not, or to identify different classes of network attacks such as scanning or spoofing. In unsupervised learning problems, the main task is to find patterns, structures, or knowledge in unlabeled data, which is data-driven approach. So in the area of cybersecurity, cyber attacks like malware, normally they stay hidden in some ways, include changing their behavior dynamically and autonomously to avoid detection. With clustering techniques, type of unsupervised learning, we can use it to help to uncover the hidden patterns and also structures from the data sets to identify indicators of such sophisticated attacks. Similarly, in identifying anomalies, so and also policy violations, detecting and also eliminating noisy instances in data. Clustering techniques can be useful. For instance, there is an approach for detecting botnet traffic or malicious cyber activities using reinforcement learning, with combining with neural network classifier. So, and in reinforcement techniques are another type of machine learning that characterize an agent by creating its own learning experience through interacting directly with the environment, so, i.e. environment-driven approach, so where the environment is typically formulated as a Markov decision process and take decision based on reward function. So some of the example of the machine learning used in cybersecurity, for example, they use like different technique like SVM to classify various attacks such as DOS or probe attacks, or SVM and KNN together to build intrusion detection system using knife Bayes to build again the IDS for multi-class classification. And also decision tree has been used for feature selection and to build an effective network intrusion detection system applied by this researcher here on combination using decision tree and KNN for anomaly intrusion detection system, random forest, and also deep and reinforcement learning, and also ANN to build intrusion detection system for SDN. So this is example of different types of machine learning that's been applied in cybersecurity successfully. And more and more system will aspect or machine learning will be used in this field because of this its effectiveness. When we do the example of application of machine learning for anomaly detection in IoT environment, for example. So this is the steps that we normally use. So data collection with the data contains and then data pre-processing, which include data cleaning, visualization, feature engineering, and vectorization, and then sampling. With use training data and also testing data. And then we apply after training data, we apply with learning algorithm using different algorithm, for example, using regression or SVM, decision tree, etc. Then generate final model. And finally, we have the model evaluation that can be used tested with the testing data if our algorithm and compare it with algorithm is more effective, more practical, etc. So some of the machine learning based intrusion detection system that we've been applied. So this is the IDS, the machine learning based IDS for the software defined networks. So in figure listed below is we apply the machine learning techniques using ANN. We illustrate the figure illustrate the obtained performance measurement of graph and confusing metrics to evaluate the performance of design IDS model for the software defined networks. So in this graph, the model shows high detection accuracy of 97.4% in detecting attacks with training set, and 97% on testing set, while overall accuracy is about 97.4. So when we look at specifically the taxonomy of the intrusion detection system, we can see how machine learning has been used, like different types of machine learning has been used in IDS or intrusion detection system. So from the ANN Bayesian to KNN, SVM, decision tree, etc. So a lot of applied mathematics and statistics is being used in intrusion detection system, specifically in the cybersecurity field. Yes, so in summary, so changing cyber threat landscape, so cyber attacks growing significantly in terms of quantity and quality. So paradigm shift in cybersecurity with the use of data science and AI as the main actors, because security is all about the data. So data science can make a massive shift in cybersecurity technology and operations, where also machine learning algorithm, they can be used to learn or extract insight of security data for their detection and prevention. Okay, thank you for your attention.
Okay, thank you very much, Dr. Pranggono, for your interesting presentation. Now we come to the next keynote speaker. Our fifth distinguished speaker now, Dr. Siti Zanaria Satari. Dr. Siti Zanaria Satari obtained her PhD in statistics from University of Malaya in 2015 and currently is the head of program data analytics at the Center for Mathematical Science, University Malaysia, Pahang. Her general research interest is in statistics and data analytics, and her main research contribution have been in the areas of circular statistics, circular regression model, functional relationship model for circular data, outlier detection for circular regression model, and so on. Currently, she focuses on developing clustering-based procedure for identifying outliers in circular anatomical data and actively involved in designing multi-track system for academic staff in UMP. As senior lecturer, she has experience in teaching, developing syllabus, and module writing for various statistics and mathematics courses such as storytelling, data visualization, counting, probability, elementary statistics, applied statistics, and so on. Today, Dr. Zanaria will share with us about her research entitled Outliers Detection for Circular Data. Please welcome Dr. Zanaria to the Zoom stage. Dr. Zanaria, time is yours. Yes,
All right.
for 30 minutes.
All right. Thank you, program committee. Can you hear me?
Yes, clear, very clear.
Let me share my screen first.
Yes.
Share screen. Can you see my screen now?
Yes, doctor.
All right. Okay, let me. Right, thank you again, the program committee Icompac 2020 for having me today as one of the keynote speaker. And sorry that I request as last presenter today. Okay. So my title of presentation today is Outliers Detection for Circular Data, and my name is Icompac from UMP. Stand for Are you missing Mr. Pahang? All right. So, as mentioned by the host just now, my main research interests are in the areas of circular statistics. So, in a while, I will introduce to you what is circular statistics, because this area is actually maybe like alien for some of you. Okay, so I will introduce what is circular statistic, and my main interest is actually in detecting outliers for circular data, and I'm also expert in S+, R, and Tableau, and currently I am the head of program data analytics in UNP, a new bachelor program in UC Malaysia Pahang. Okay, so before that, I would like to introduce some of my recent work on outlier detection for circular data. So from 2016 to 2019, I am focusing on developing clustering-based procedure for detection multiple outlier in circular model with application of wind direction data, and recently, I'm focusing on identifying outliers, but for univariate circular biomedical data, or focusing in craniosynostosis syndrome, and with collaboration with medical center in Kuala Lumpur, PPUM. Okay, and work with real data set for craniosynostosis syndrome. Okay, so the outline of my presentation today involve the abstract, what's I will trying to talk today, and some little bit introduction to circular statistics and the research focus for this presentation, and followed by the outliers, overview of outliers in univariate circular data, and also overviews outliers in bivariate circular data. And for each subtopic here, I will also give my overview and also suggestion, because both of these areas is actually my main research area. Okay, so today I will talk about circular data and focusing on univariate and bivariate circular data. And for the univariate, focus with mostly for von Mises distribution, and for bivariate data is actually for regression analysis. Okay, so we will talk about outlier detection for circular regression model. So basically what I will try to talk today is about the strength and weakness of the methods that is used to detect outliers in both types of data, univariate and bivariate data, and also discuss the future research. Okay, if there is interest from the participant as well from the committee, okay, I will like to collaborate with you. Okay. So first, introduction of circular statistic. Alright, so what is circular statistic? Actually, it is called circular statistic because we deal with data that involve circular type. Okay, what is circular type of data? When the data are measured in degrees or radian. Okay, so normally in statistics we deal with linear data. Okay, but we tend to forget that some of the data are measured in degrees or radian. So if your data are measured in degrees or radian, you should not treat it as in linear statistical method, but you have to treat it using special method called as circular statistic. Okay, so some of the example of circular data involve compass direction, because when we said about direction, okay, such as wind direction, compass direction, wave direction, okay, all of these are measured in degrees or radian. And currently, I'm working with craniosynostosis syndrome data, in which we measure angle, okay, from the skull of patient, okay, to detect abnormality. That one is also measured in radian. Okay, the data is in radian. Okay, and most application of circular statistics can be found in meteorology, because and I mentioned just now, my previous study mostly focusing on wind direction data, so that one is meteorology, and currently I'm focusing on medical data. Okay, so of course, since the research in circular statistics focusing on circular data, so there are so many new theories and finding can be developed. Okay, more and more theories can be developed by many researchers in recent years, because it's actually quite new area. Okay, so if I'm not mistaken, starting from 1967, something like that. So just new. And for your information, if you have a background in linear statistic, you can always convert it into circular statistic by changing the type of data. But when you dealing with circular data, you have to take note that okay, the data should be treated as circular and normally involve trigonometry. Okay. Just overview. Okay, when it's circular data, so also they have quite similar representation, uh, like in linear data. So also here we have measure of center. Okay, so we call it a measure of location of center, and also concentration. Okay, so for measure of location and concentration in linear data, normally the concentration um, uh, is described by variance, but here okay will be described by mean resultant length or by concentration parameter or kappa. Okay, and in linear data we have mean value, so here also we have mean donated by mean direction. Okay, so this is what I mentioned just now. We have also variance and also standard deviation. Okay, and if in the linear data or linear statistic, we have normal distribution. In circular statistic, we have von Mises distribution. Okay, so this is actually when we illustrate the data, it's more likely similar, the diagram most likely similar with normal distribution, but here we the parameter involve kappa and mu. Okay, mu is mean direction and kappa is the concentration parameter. Contrast with the linear method. In linear data, for linear statistic, we have mu, mean value, population means, and also variance sigma. Okay, and of course, there are so many other distribution in circular statistic, but von Mises is the most popular one because most of data is actually distribute using the von Mises type. Okay, so for today talk, I will focus on univariate and bivariate circular data, and focusing on method of detecting outliers for both type of data. So just a brief introduction of outliers in circular data. Okay, so as we know that outliers are any observation or data point that differs significantly from other observation. It can be very small value or very extreme value, and sometimes it's become unnoticed because it's too close with other inliers data. Okay, so in circular data, normally outlier is related to the abnormality, because let's say when we just now I'm talking about my application in wind direction and in the medical data. So in medical data, normally when we detect the outlier is actually the abnormality. As example, when I apply it with a craniosynostosis syndrome patient. So actually the outliers is actually for the patient with the syndrome. Okay, so that is why the study in circular statistics is very popular nowadays. Okay, and of course, when we have outliers, it may affect the final outcome of our data analysis or inferences and may lead to a wrong decision making. Okay, so for each outlier detection research, okay, so if we propose any method to detect outliers, so we have to go through some simulation study to investigate the performance of the method. So normally in my research and most of the research in circular statistic, okay, in detection of outlier, we have to go through these three types of measurement in which we have to calculate success probability denoted by P out, the masking error P mas, and the swamping error. So the swamping error occur when inlying observation is identified as outlier, and while for masking error occur when the outlier is not detected. And of course, the P out is actually the probability when the outlier is successfully detected. Okay, so and the indicator that we have to take note that, okay, we in each method we need to observe a large value of P out, small value of P mas, and small value for P swam. And when it is good when the P out value approaching to 1 and the P mas and P swam value approaching to 0. Okay, so focusing more on the first major part in my presentation today. Okay, so outliers in univariate circular data. Okay, so when we wanted to detecting outliers in circular univariate data, there are four major part we have to consider. First, you have to know the data distribution. Okay, because similar with a linear environment, so circular data also have so many type of distribution. As I mentioned just now, the main or the most popular one is the von Mises distribution, but it may become from the other type of data distribution such as uniform or red normal. Okay, and then we have to identify the method of detecting outliers, and then we have to consider when investigating the performance, we have to investigate from various angle of outlier scenario, and also finally to investigate or to calculate the effectiveness of the proposed method, we have to calculate P out, P mas, and P swam. Okay, so first of all, let me introduce an example of outliers in univariate circular data. This is actually a very popular historical data in circular statistics, where the data is actually data of homing ability of the 14 frogs, okay, recorded in a series experiment by Ferguson in 1967. And what happened here is in the experiment, okay, after 30 hours of enclosure within the dark environmental chamber, the frog were released, and the direction taken by the frog were recorded. And when we said about direction, the direction here is illustrated using okay, the measurement is by degree from 0 to 360 degree. And obviously here, the observation 14 is a candidate of outliers, and it's already detected by many researchers that 14 is outlier. But for this example, it is the outlier here is situated quite far from the other inlying observation, so it is quite easy to use graphical. But in reality, some of the outlier is actually too close with the other data sets, so that is why maybe the graphical technique is not that useful here. Okay, so this is an example the effect of outliers in this frog data. Okay, let's suppose that we exclude observation 14 and denote the data as data set 2, means that data set 1 include observation 14 and data set 2 exclude observation 14. Okay, so we can see that the discrete analysis gives us a different value. Okay, so here we can see the effect of the outlier. We can see that the mean direction of dataset 2 is moving very slightly to 145.0843, but not that different, the value. Okay, but something that we have to note that, okay, similar with linear type of data, okay, so the what we call the concentration or the dispersion of the data, when the data more dispersed means that maybe there is an outlier. Okay, so here in circular statistic, we are looking at the concentration value. such as the value of variation, standard deviation, or concentration parameter. We can see that, okay, as example, the concentration parameter kappa. Okay, data set 1, when we have outliers observation 14, the kappa value is 2.17, while the in data set 2, the value increased to 3.8. Okay, so for circular statistic, okay, so when the kappa value are larger, means that the concentration is higher, means that the data is better. Okay, so means that here, when we exclude the observation 14, which is the outlier, okay, the data set become more consistent. Okay, that is why in so many application, we have to identify outliers and remove it if possible. Okay.
Dr. Zanaria, sorry, I would like to remind you that the time is 5 minutes left.
Okay.
Thank you. Yeah, sorry.
All right. Okay, let me fast forward. Okay, so okay, so let me introduce some method of detecting outliers in univariate circular data. So we can divide or group the method by 4 types, which is graphical, numerical, robust, and clustering. So here I list the graphical techniques that have been introduced. This one is for the numerical technique. But the disadvantage of numerical technique here is normally we can only detect one single outlier at one time. That is why more current researcher focus on using robust technique and clustering technique, because it has advantage when we can identify or detecting outlier, multiple outlier at one time. Okay, so for outliers, okay, for suggestion for future research, I would suggest for other research, if interested to invest in this type of research. As for the method, actually only a few researchers now focus on robust method, clustering method, and robust clustering method. So we can try to figure out many other methods here from this type of algorithm. And for the outlier scenario, most of the current researcher is actually focused on shift the mean only. Okay, but we can also focus with shifting the kappa and shift the kappa and mean simultaneously. And also currently, because we are in the era of big data, we also need to deal with large data set. Okay, and for the second part of my topic today, outliers in bivariate circular data. Okay, similarly here we have the stage. And here we should focus in the regression model, because a different type of model will yield different type of method. Okay, and just some introduction of circular regression model. There are 3 types of circular regression model, which is circular regression model, circular linear regression model, and linear circular regression model. And most of the research on outlier detection right now is just focusing on circular regression model. So again, there are so many what we call chances to introduce methods in detecting outliers in this area. Okay, this is one of the most popular regression model. Okay, and here I'm introducing common method of detecting outliers in bivariate, sorry for the title, bivariate circular data. So here the most popular one is similarly graphical, numerical, and clustering. But compared with the univariate, actually the clustering method in bivariate circular data is more well developed. Okay, so starting 2013, actually, researcher shift their research to clustering technique, because again there is a limitation of row deletion technique. Okay, and you can see here Young et al. Starting 2014 introduced mean shift based clustering, and followed by me in 2015, and so many others researcher until recently. And in clustering technique, in outlier detection for bivariate, Okay, so most of the researcher actually focusing on outlier in one space only, which is in V space or the response variable. But my research recently, I'm focusing on 3 outlier scenario, which is in U space. Okay, so and in V space and also both in UV space. And for further research or future research, I would like to suggest other researcher to focus on other type of regression model. Just like I said just now, there are 3 type of regression model. So and then also you could also explore on robust clustering method. This one no one doing it already. And also for the outlier scenario, especially for circular linear regression model or linear circular regression model. And also again, we have to deal with large data set, okay, with the current era. And if you're interested in a clustering algorithm, okay, this is the some of overview of clustering algorithm that normally used in linear data. And for your information, any method here can always be applied to circular data. And we have to modify the similarity measure because of the nature of the data. Okay, that is why the research in this area has so many great future. And okay, that's all from me. And I'd like to thanks special to Icompac committee for having me today, and also for my dean, okay, Dr. Prozuki, my former supervisor, and also my PhD student for helping me. And this is my side from my faculty. Okay, feel free to visit. And that's all. Thank you.
Okay, thank you very much, Dr. Zanaria, for the beautiful presentation. Now we have a question and answer session for around 30 minutes for all of the keynote speaker, our distinguished speakers. And I would like to invite our distinguished participants of Icompac to deliver the question by raising hand or writing in the chat room. And for this session, there will be 2 questions by raising hands and 2 questions by writing in the chat. Currently, I already have 2 questions in the chat. Now, I would like to invite the participant to give a question or opinion by raising hand and directly deliver the question to our distinguished speaker, please. Is there any participant raising hands to deliver the question? Okay, while we are waiting, I would like to read the question from the chat. And there are 2 questions for Professor Masaki Kameko. The first question is from Valentino Rizali from Gajah Mada University. The question is, for the definition of generalized cohomology, can we choose any index for the grading of the graded group, or there is a restriction for this?
Okay.
Okay.
Usually, so the grading is based on the integers. Okay. So we usually have the grading 0, 1, 2, 3, 4, 5, blah, blah, blah. And well, -1, -2, -3, blah, blah, blah. Okay. But sometimes if we use the periodic cohomology theory, like K-theory, to be precise, the complex K-theory, then we have only 2 gradings, 0 and 1. we can consider integer valued gradings, but essentially K0 is equal to K3 and K3 is equal to K5. So we don't need integer indexing, okay? And yeah, maybe you can come up with a other kind of indexing. For example, if you consider group action on this space, then you can take the representation of that group and consider the representation valued generalized cohomology. But we usually call it equivariant cohomology. And in my opinion, they are slightly different from the so-called generalized cohomology theory.
Okay.
Is it okay?
Yeah. Mr. Falan, Mr. Rizali, do you still have any question to Professor Kamiko? Not yet. Okay, I would like to have the second question. This is for Professor Kamiko also, from Max Rizal, from Institute Science and Business. The question is there an opportunity this concept, Lie group, in computer security theory?
I have no idea about that perspective, but Lie groups represents certain symmetries. Okay, and if you deal with symmetries, then you have a good chance of encounter Lie groups. Okay, maybe you first you encounter with say a finite group or something like that, say symmetric group or cyclic group. But if you deal with some continuous data, then you might encounter with Lie groups. Okay. It may not be a good answer for you, but that's all I can offer you right now.
Okay. Okay, thank you very much, Professor Kamiko. We hope that the answer will be very good for the participant. And now I would like to invite the Bapak Khairul Imran from Department of Mathematics of ITS to deliver the question to the keynote speakers. Please, Bapak Khairul Imran, you can deliver the question directly to the speakers. Pak Imran?
Yes, okay.
Oh, yeah.
Thank you.
Okay.
Thank you for the opportunity, Mrs. Indah. So I would like to ask Professor Anderson. So in your presentation, as far as I understand, you mentioned that the universe is getting bigger. Yeah, I'm interested to this statement. So if we observe that an object is getting bigger, of course we can measure the object directly, like a table or another small object. But here the statement is that the universe is getting bigger. So how can we observe? How can we know that it is getting bigger? Because it is very difficult to measure the universe, I think. So you can explain about it more. Thank you.
Yes, of course. Yes, that's a very good question, and one that's often asked. So we believe that the universe is flat. As I mentioned, there were three options right at the beginning there. It could be closed or open or flat. If it's flat, then it's effectively an infinite space, infinite three-dimensional space at every time step. And so, of course, yeah, you're quite right. There is no such thing as the size of an infinite universe. When I said that the universe is expanding, that refers to the scale factor, the factor A of t, that is getting larger as time goes on. And the way that we can see that directly is by measuring the velocities of the galaxies that we can observe. So, and this is a project that was done first very extensively in the 1920s to discover the expansion of the universe. And the person who's most familiar with this is Hubble. Edwin Hubble, and the law that the universe is expanding is named after him as Hubble's law. But the idea is that if you look in any direction and you measure the velocities of galaxies, which you can do by measuring the red shift of the light that we receive from those galaxies. And so if the galaxies are moving away, then the light is shifted to the red, and if they're moving towards us, it's shifted to the blue. And it turns out that almost all the galaxies, there are some exceptions, galaxies that are very close to us, some of them are moving towards us, but the vast majority of galaxies are moving away, and they're moving away at a speed that you can measure again just from the red shift of the light that we receive. The speed that they are moving away increases linearly with the distance to the galaxy. And so this is consistent with the model that I mentioned there, with the scale factor A(t) getting larger and larger with time. So as we go back in time, all the galaxies were closer together, and in the far future, they'll be much further apart. And that's what we mean by the expansion of the universe. I hope that explains.
Okay, thank you. Maybe one more question, if there is still enough time. So
Yes, please.
Yeah. Do you think the volume of the Earth is also expanding from time to time? Thank you.
Well, I'm not a geologist. I'm not a geologist, so I don't know. But again, this is something that when people hear that the universe is expanding, yeah, quite often they think, does that mean, or they ask anyway, does that mean that the space between atoms is expanding, for example? And of course, if it was, that would mean that the Earth was expanding as well. But the force that keeps the particles of the Earth together, the electromagnetic forces, is far, far stronger than any force due to gravity. And so the answer is no. The atoms don't expand as the universe expands. And so it's unlikely, I mean, I'm not a geologist, but I think it's unlikely that the Earth itself is expanding as the universe expands. We're talking about the distances between the galaxies, basically. Even the galaxies themselves, within the galaxies, they're not expanding either because they are gravitationally bound. But it's distances between the galaxies that are getting larger as time goes on.
Okay, thank you. Thank you very much, Professor Anderson.
Okay, thank you, Pak Khairul Imran. Thank you, Anderson. Now, I would like to invite Imra Tusiama from Department of Mathematics of ITS. She's raising her hands. And can you unmute your microphone, please? Imra Tusiama. Oh, I will go to Dito Putra Ripala. Would you please unmute?
Okay, thank you. Okay, thank you for the opportunity. I would like to ask to Mr. Anderson. I have two questions. The first is, can you give me the example? What is the example of perturbating from the cosmology? And the second is, I have read there's a paper written by Stephen Hawking. There's a wave function of the universe. As we know, if we have a wave function, we can measure momentum or position and etc. And what is your opinion about that? Thank you.
Okay, so yeah, so your first question was, what do we mean by perturbations? I think you mean that. So as I said, the idea is that the universe is not completely homogeneous. As a good first approximation, the universe looks on large scales to be homogeneous, and which means it's the same everywhere at a given time. But of course, that's obviously not true in the real world. I mean, we're sitting in our offices or whatever, and we see that things are different everywhere. And obviously, if the universe was homogeneous, it'd be very boring. There'd be no life or anything like that. So this is what we mean by the perturbations. It's just the deviation between this very idealized model, which assumes that everything is the same at any time step. The universe is homogeneous. In other words, the deviation between that model and the real universe. That's what we mean by a perturbation. And there are people who believe, I mean, as I said, it's fairly difficult to even specify that directly because there are different gauge choices. And so if you make one choice, which is say one identification between the real universe and this idealized universe, you get a certain set of perturbations. And if you make another one, you get another completely different set of perturbations. And there are some people who believe that these perturbations are not even small, and therefore the entire program that I described in my talk there about linear perturbations is misleading. So it's quite a complicated question, but yeah, it really in the end it's the mismatch between our very idealized simple model of the universe, which is due to Einstein and various people 100 years ago, and the universe as it is today. And if we describe the universe using a metric tensor, we're talking about the differences between those two metric tensors, but making that mathematically precise, as I said, is hard. Your second question related to Stephen Hawking's work on the wave function of the universe. So this is a topic that's slightly outside what I was talking about, because there is well, I wouldn't say alternative, but there is a description of the universe that involves quantum mechanics, which what I was talking about had no reference to quantum mechanics at all, except insofar as the perturbations that we see that formed the structure of the stars and the galaxies around us today are believed to be due to quantum fluctuations in the very early universe during the inflationary stage. So yeah, there's been a long program of quantum cosmology that's associated with the names of people like Hawking and Hartle. And yeah, they try and model the universe as a quantum system, essentially. And so if you do that, you end up constructing a wave function for the universe. And again, this wave function has the same kind of mathematical problems associated with it that the classical picture of the universe does, because you can assume that the wave function is homogeneous and isotropic, and then you get a very simple model that you can solve for. In that situation, the evolution of the universe is somewhat different. At least in the earlier stages, it's quite different from the classical model, because at the earlier stages, the densities are very high and you get quantum effects occurring. But yeah, it's a different program. Yeah, you can use that to define various quantum properties of the universe, but I think most people would regard it as highly speculative at the moment, and it hasn't really got us anywhere in terms of our understanding of the universe, the way the universe evolves. And if there are any differences between the quantum picture and the classical picture, there would only be in the very, very early phases of the universe during inflation, which is again outside the scope of what I was talking about in my talk. I hope that answers your question.
Okay, thank you.
Okay, thank you, Dr. Anderson and Mr. Tito. Would you like to inform us where do you come from? I mean, your institution?
Oh, I'm from Department of Physics ITS Surabaya.
Oh, okay, thank you. Thank you. Now, I think we can have one more question. I would like to invite Ashraf Mansur to deliver the question to our keynote speaker, please.
Hi, Assalamualaikum and hello everyone. Okay, I would like to pose a question to Dr. Zanaria. Can you hear me? Okay, Dr. Zanaria, I would like to ask, this is out of my curiosity only. So since you are doing circular statistic, right? So can the circular regression model be applied in time series data? or is there any what we call that data that cannot be handled by your circular regression model? That's all.
Thank you, Mr. Ashraf. All right. So I guess you're curious on a time series on circular data. And for your information, so all method in linear data can be applied to circular data as long as the data is converted or the data are measured in degree or radian. And if you have certain data that is versus time, okay, circular versus time, so you can use time series, and you could modify the method and actually change a certain I guess the method. You have to consider trigonometry inside the time series method, and I hope it answer your question, curiosity.
Okay, thank you so much, Dr. Zanaria.
All right.
Okay. Thank you, Dr. Zanaria, and thank you, Pak Ashraf. Would you like to inform us where do you come from?
Yeah, Assalamualaikum. I am Ashraf from School of Teaching Education, Mathematics Department, University Science Malaysia. Okay.
Okay, thank you. Thank you. We still have around about 10 minutes time. I would like to re-invite Imro Atusiyama. Are you ready to deliver the question to the keynote speakers? Not yet. So I open one more question session to deliver from all the participants. Would you like to raise your hand to deliver the question? Not yet. Okay. So I would like to have a question to Dr. Prangono about the use of machine learning regarding to the pandemic we face about the use of machine learning in participating to what is it to evaluate the COVID-19 pandemic. Would you like? So that is my question, Dr. Prangono.
Thank you, but sorry, actually, can you repeat your question because my connection
Okay,
was
sorry.
not that good, I think. Yeah.
Okay. Would you like to share with us about the use of machine learning in your area regarding to the pandemic that we face nowadays? Thank you.
Okay, so well, machine learning has also been used to predict the number of the COVID-19. So we had one paper, but we didn't use machine learning basically because with machine learning, you need at least some of data available. So when we got our paper, it was on April, I think. So it's not much data that we have. So yes, some researchers, they also use this machine learning to predict when the pandemic will be end, or how pandemic will be end, etc., and what is the distribution, etc., for the R naught, etc. So that's been used in regarding to this pandemic. Okay, does that answer your question?
Okay, I still have one more question. Is it that strong for machine learning to be used in predicting, for example, the pandemic spread? How strong is the method?
Well, because this pandemic is not really common, isn't it? I mean, the last pandemic that we have is it in 1800s. So with the machine learning, it's basically normally you will need a data like the bigger the data or the longer term of the data, so the more accurate prediction. But especially with this pandemic, because well, the prediction, well, the earlier research they predict they will finish or the pandemic will be end by, well, in the summer or the end of this year. But yes, so it's not looks like it, isn't it? So every country is now they facing the second waves everywhere. Here in the Europe, we facing second waves, which is well, it's not as bad the first wave, but like Indonesia actually, so it's probably still on first wave. Yes, so but machine learning actually has been used in any field, any discipline, and well, when we when people trying to use it a lot, so they know how well they for the specifically for the pandemic. Well, because it's still early, and this is the pandemic is not. This pandemic is really a rare pandemic. So I think people are still learning how to use this machine learning to effectively predict the pandemic. Okay.
Okay, thank you.
Yeah.
Thank you,
Okay.
Dr.
Thank you.
Pranggana. Still, we still have around 5 minutes time. I would like to invite another participant. Would you like please to deliver the question directly to our keynote speakers? Okay, not yet. I would like to also have one more question to Ibu Valeriana. Ibu?
Yes.
Yeah. Would you like to share with us how far is the use of operation research in Indonesia regarding to evaluate the inventories? Thank you.
Yes, okay. In the inventory management, we have regarding stock, talk about the stock management model in operation research differ in nature and available information, the properties of the system. When the value model parameter will define method of corresponding mathematical model is deterministic. If it is a parameter of the system, random value with no probability distribution model as stochastic. If all model parameter do not change over time, it's called static, like this. We have also development in the inventory management model. We have following characteristic into the account. We have a demand characteristic of part, yeah, part. We have a nature of product, the product type, dimension, identify and consider a certain product characteristic. For instance, a product may be perishable, consumable, repairable, or recoverable. Deteriorating an item in the storage period and the natural process. Therefore, it can be ignored inventory policy. It may be different in storage place due to differences in the environment. And then we have type of demand, type of demand could be classified. It's so like a deterministic demand is exactly no. Unlike the probabilistic demand, it can be, we have two type, as I show you in my PPT, and and then we have on the basis of demand source, demand are divided into independent and dependent, and then we have a nature of supply process. The nature of supply process refer any restriction or constraint we impose an inbound process in the supply chain. We have a general model in operation research. Objective function, we have a maximum and minimum order size, something like that. We have identified possible form of lead time, and then we have lead time. Its replacement is no, whether a second of replacement arrive after a random time of final form. A seasonal factor may be effect to the time takes in order to be fulfilled. Maybe like this.
Okay, thank you, to Dr. Valeriana. I received one more last question from Pak Subhan, our head of department. I would like to invite Pak Subhan. Would you like, please deliver the question?
Okay, thank you, Ms. Enda, for the opportunity. First of all, I would like to thanks to all speakers for your great presentation. Thanks a lot as the head of the Department of Mathematics. And secondly, I would like to ask to Prof. Bernardi Prangono, actually. Actually, simple question, Prof. Bernardi. I'm sorry, Prof. Bernardi, you are very early in the morning at this time, in UK. My question is regarding the cryptography. You know, in mathematics, we have applied algebra, which is related to cryptography. How far actually in cybersecurity do you use this subject, this area? That's my question, Prof. Bernardi. Thanks a lot.
Okay, thank you. So yes, well, even though cryptography is not my main area, so we use it a lot actually. So in any like a connection. So for example, that we, for example, when we use the secure HTTP, for example, using HTTPS instead of HTTP. So we use some kind of cryptography to encrypt the traffics, so people cannot, well, read the traffic without decrypting it. So we use it a lot, but actually one of the main, well, the main issue or the future issue of this cryptography is, I don't know if you heard about the quantum computing. So with the quantum computing, basically, well, potentially, they will break all this cryptography. If the normal encryption normally today, they will takes 1 year or maybe 2 years to compute. With the current computer that we have, with the quantum computing, is potentially they can break this encryption with 1 or 2 minutes. So this is probably the the work for a mathematician like yourself to solve what happens if we have quantum computing. They already have some big companies. They already have in like Google, etc. So, and they're preparing how we to face the challenges when the quantum computing is available. about this encryption and cryptography. Yeah, I hope
Okay.
this answer
Okay,
your
thank you
question.
very much. Again, thank you very much to Prof. Kameko, Prof. Anderson, Prof. Bernardi, Prof. Satari, Prof. Valeriana for joining for this conference. Thank you very much, Bu Enda.
Thank you. Terima kasih.
Thank you very much.
Subhan.
Makasih.
Okay, because the time is limited, I would like to summarize this plenary talk, and I would like to highlight some issues. First, the cohomology of classifying spaces, which is based on algebraic theory, might be useful for field of material science. As we know, material science is very familiar in our daily life. And second, cosmology, perturbation theory, is related to the structure of the universe on the largest of scales. And third, management of inventory based on data is important as it affects the productivity of an organization. And fourth, security is all about data, and data science can be used to learn or extract insights of security data in many fields of application. And the last is circular data and data analytics with so many applications for future research. As a moderator of this session, I would like to deliver great appreciation to our special keynote speaker for sharing their research and knowledge with all of us here. I would like also to thanks to all the conference guests for their participation in this session. As a moderator, I close the session and return the Zoom stage to the MC. And I would like to say Assalamualaikum warahmatullahi wabarakatuh, and see you in the next opportunity.
Thank you, keynote speakers and moderator, for the wonderful presentation. And to capture this wonderful occasion, we would like to once again invite our honorable guests and participants to have a photo session. In this photo session, you may pose freely as you like. And please, once again, kindly activate your Zoom video so that we can start our photo session. Okay, since everyone is ready with their camera, so I will count to 3 and then our committee will take the photos. 1, 2, 3. Moving on to the next slide. 1, 2, 3. Okay, then to the other slides as well. 1, 2, 3. Okay, that was a great photo, everyone.
Ladies and gentlemen, we will now have our lunch break up to 12 p.m. Please note that you have to return to Icompac 2020 Zoom meeting by 12:00 p.m. GMT +7 to continue with our parallel sessions. For the sessions, if you are a presenter participant, please join the Zoom link for your respective classes right away at 12:00 p.m. as according to the numbers assigned. Additionally, afterwards, if you're interested to join another class in another Zoom link, our committee will be sending out the links in the chat box which you may join from. Once again, please note that you have to return to Icompac 2020 Zoom meetings by 12:00 p.m. GMT +7 to continue with our parallel sessions. Please note that we will be closing Icompac 2020 after the parallel sessions, and the committee will send out your certificates of participation in 7 days.
Thank you, Prof.
Finally, ladies and gentlemen, thank you for coming to the International Conference on Mathematics, Pure Applied and Computation 2020. My name is Johanna Nuryadi.
And my name is Samara Rana, and we sincerely apologize for any mistakes we may have made in presenting as Masters of Ceremony. Thank you very much to ITS officials, special guests, and all participants for your kind attention and cooperation. Good afternoon, and see you at the parallel session.
Pranggono masih di sana? Halo, Pak Pranggono masih di sini?
Departemen Matematika yang berdiri sejak tahun 1965 memiliki dosen yang sangat baik dan berkompeten pada bidang aljabar, analisis, matematika terapan, dan ilmu komputer. Dengan reputasinya yang sangat baik tersebut, kami dipercaya bekerja sama dengan Delft University of Technology, Vienna University of Technology, Sibaura Institute of Technology, dan juga Oxford University. Selain program sarjana, kami juga mengelola program master maupun doktoral.
Matematika ITS mendukung penuh mahasiswa dalam kegiatan akademik dan non-akademik. Dengan dukungan tersebut, mahasiswa diharapkan memperoleh pengalaman untuk dapat mengembangkan diri.
Selama saya menjadi mahasiswa Matematika ITS, saya sudah mengikuti berbagai macam kegiatan. Salah satunya yaitu sebagai panitia OMIT atau Olimpiade Matematika ITS tingkat nasional.
Untuk pengalaman Olimpiade, kebetulan saya beberapa kali ikut Olimpiade dari kampus lain, seperti Kalkulus Cup Universitas Negeri Jakarta, terus Olimpiade di Universitas Negeri Malang, UI, dan lain-lain.
Matematika ITS itu asik, dan di Matematika ITS itu kalian punya banyak kesempatan untuk eksplorasi diri. Contohnya, selama aku di Matematika ITS, aku punya kesempatan untuk eksplorasi baik bidang akademik maupun non-akademik.
Sebagai Kasubag Tata Usaha Umum, di lingkup institusi yang memang stakeholder-nya adalah mahasiswa, jadi pelayanan yang kami utamakan dalam mahasiswa.
Departemen Matematika ITS memiliki berbagai macam fasilitas yang menunjang proses belajar mengajar. Di antaranya, laboratorium, ruang baca, co-working space, ruang kelas, dan ruang sidang.
Kelima laboratorium ini berkorelasi dengan pusat penelitian yang ada di ITS, pusat unggulan yang ada di ITS, dan pusat kajian yang ada di ITS. Masing-masing laboratorium di Departemen Matematika ITS ini bertanggung jawab kepada mata kuliah yang ada di Departemen Matematika ITS, baik itu di S1, S2 maupun di S3.
Departemen Matematika ITS berkolaborasi dengan instansi lain yang menghasilkan beberapa riset.
Riset ini akan melakukan proses sortir peluru yang cacat menggunakan pengolahan citra digital. Secara garis besar, alat ini akan mengambil gambar atau citra peluru menggunakan dua kamera, yaitu bagian belakang dan bagian selongsongnya.
Proyek tugas besarku ini, aku sedang mengerjakan salah satu program tentang deteksi plat nomor kendaraan bergerak, di mana di sini aku menggunakan metode AI, Artificial Intelligence, yaitu tentang deep learning. Sekarang program ini masih dalam tahap uji coba berupa inputan data video rekaman. Diharapkannya nanti program ini bisa mengerjakan inputan data secara real time dan bisa membantu pihak kepolisian dalam memantau perkembangan lalu lintas.
Departemen Matematika ITS merupakan salah satu departemen matematika terkemuka di Indonesia yang terakreditasi A dan memperoleh sertifikasi ASEAN University Network. Selain itu, Departemen Matematika ITS juga memiliki reputasi internasional dalam bidang matematika dan komputasi.
Although we never asked for it, sometimes it's the journey that teaches you a lot about your destination. Sometimes we need to keep going to push ourselves beyond the limit. Sometimes we need to believe in something, even if it means giving up everything we have. Sometimes we have to be able to accept failure to get better. Sometimes you need those moments of struggle in order to come back up. Sometimes it's not always about how good we can be.
Ya ngono anak bapak. Bapak bangga.
But how useful we are for the people around us.
Avec les Colfort Sader.
Sobat Kampus, tahun baru selalu diidentikan dengan harapan baru menuju sesuatu yang lebih baik. Tidak terkecuali oleh Institut Teknologi 10 November. Demi menyamakan visi menyongsong tahun baru, pada tanggal 10 Januari 2020, di Gedung Geraha Institut Teknologi 10 November, dilangsungkan kegiatan pidato awal tahun oleh Rektor ITS dengan tema ITS Semangat Baru.
Kita ITS mencoba dengan semangat baru. Kita ubah ITS, kita melakukan perubahan.
Pada kesempatan tersebut, Rektor ITS menyampaikan rasa syukur dengan berdirinya ITS hingga saat ini di tahun 2020. Beliau juga menyampaikan apa saja yang perlu disiapkan oleh ITS sebagai langkah ke depan, membangun ekosistem pendidikan masa depan, mengembangkan riset dan inovasi yang berbasis pada produk unggulan, dan membangun atmosfer internasional adalah beberapa di antaranya. Langkah-langkah tersebut dilaksanakan untuk mencapai cita-cita ITS sebagai salah satu kampus terbaik dunia.
Revolusi Industri 4.0 ini kan sudah berjalan, sudah bergerak, sudah masuk di lini di mana-mana. Maka ITS harus berubah. ITS harus berubah. Di 2020, sesungguhnya kita juga sudah bergerak, namun lebih kita harmonisasikan. Di 2020, kita ingin anak-anak kita, mahasiswa ITS, itu bisa mendapat sentuhan teknologi industri revolusi 4.0 di dalam perkuliahannya, di dalam materi kuliahnya. Jadi akan ada adjustment kurikulum, ya, akan ada pemanfaatan teknologi dalam pembelajaran, akan ada beberapa digital apps untuk membantu di sistem administrasi, di layanan dan seterusnya. Ya, jadi memanfaatkan teknologi juga memberikan teknologi kepada materi yang diajarkan kepada anak-anak mahasiswa ITS.
Tentunya kita berharap dengan kerjasama berbagai elemen di dalam ITS, mulai dari mahasiswa, sivitas akademika, dan berbagai pihak lainnya, harapan dan cita-cita ITS dapat terwujud. Dari Gedung Geraha Institut Teknologi 10 November, Kru ITS TV melaporkan.
Institute Technology Sepul Napemba, or better known as ITS Surabaya, was founded in the second largest city in Indonesia, famous for its diverse culture and people, has been recorded as one of the pioneers of education in the field of technology. Prioritizing quality in research and innovation, ITS Surabaya had been crowned with various awards. Occupying a large area of 180 hectares as its main campus, ITS has 20,000 students, 1,000 academic staff, 1,000 non-academic staff, and 39 departments. Study program at ITS consists of vocational program, bachelor program, master program, and doctoral program. ITS inventing many technological innovations that have been acknowledged in various international competitions. These are several national and international achievements by ITS.
ITS, within the next 5 years, it would be a research and innovative university. It means that ITS will be playing a big role in the region, especially in Asia. For the next long term, in 2045, ITS would be an entrepreneurial university. Means that it having a big role playing in the global world.
So, come and join us.
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 Come and join with us. ITS.
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 ITS. University of Heroes.
Berawal dari mimpi membangun negeri. Yayasan Perguruan Tinggi Teknik didirikan dari tangan Dr. Angka Nitisastro dan PII Jawa Timur. 3 tahun berlalu, statusnya pun berubah menjadi Institut Teknologi 10 November Surabaya. Perubahan menjadi perguruan tinggi menetapkan disnatalis pertama jatuh tanggal 10 November. Fakultas-fakultas baru pun dibuka. Tahun 77, pembangunan kampus Sukolilo dimulai dan diresmikan 5 tahun kemudian. Pengembangan SDM pun melahirkan doktor-doktor baru. Hingga 2008, ITS ditetapkan sebagai Badan Layanan Umum. Ditetapkan sebagai PTNBH, ITS kini melakukan pengelolaan otonom di bidang akademik, norma, dan seluruh kebijakan operasional. Berbagai inovasi diciptakan, salah satunya mobil listrik yang kini telah menjadi mobil listrik nasional. Prestasi demi prestasi pun diraih. Dan setiap kemajuan ITS tentu tidak lepas dari perjuangan para rektor dalam memimpin kampus ini ke arah yang lebih baik.
Perkembangan teknologi terus bergerak dinamis dan mempercepat pembangunan masyarakat masa kini. Program ID 4.0 diusung untuk mempersiapkan ITS menjadi Education World Class Research and Innovative University 4.0 agar selalu menjadi institusi pendidikan yang terdepan di bidang teknologi. Penyempurnaan ITS tidak akan pernah berhenti demi kejayaan Ibu Pertiwi.
Tahun ITS, Borderless Sustainable Technology.
Puji syukur kita panjatkan kehadirat Allah Subhanahu wa Ta'ala yang telah memberikan anugerah yang luar biasa kepada ITS. Sejak berdiri hingga tahun 2020 hari ini, ITS telah berganti pimpinan 12 orang rektor dengan tantangan yang berbeda-beda sesuai zamannya masing-masing. Untuk itu, kami ucapkan terima kasih dan apresiasi yang setinggi-tingginya kepada seluruh sivitas akademika dan kepada seluruh pemimpin ITS pada periode-periode sebelumnya yang telah memberikan fondasi kuat kepada ITS untuk terus berinovasi dan berkembang. Mengawali tahun 2020, ITS dengan struktur organisasi baru, dengan personel-personel baru. Mari kita langkahkan membangun ITS dengan semangat baru. Bermodalkan semangat dan kerjasama erat 3 organ, serta seluruh sivitas akademika, ITS ingin mengembangkan jejaring nasional dan internasional untuk mendukung perencanaan strategis dalam mencapai visi. Mari kita langkahkan perbaikan internal dan transformasi ITS dengan semangat baru untuk membangun SDM unggul ITS, baik mahasiswa, dosen, maupun tenaga kependidikan untuk mengharmonisasikan kemampuan nalar, talenta, dan karakter unggul. Tenaga kependidikan berkontribusi penting dalam memberikan layanan teknis dan administrasi secara prima pada proses akademik dan non-akademik di seluruh level organisasi. Mari kita langkahkan perbaikan sistem dalam berbagai bidang. Kita bangun lingkungan dan tata kelola prima dalam bidang keuangan. Transformasi digital dalam hal layanan dan sistem administrasi, serta mari kita jadikan kampus ITS sebagai kampus bersih dan ramah lingkungan. Seiring dengan berkembangnya revolusi industri 4.0 yang mendisrupsi segala sektor kehidupan manusia, ITS menyiapkan beberapa langkah strategis. Sebagai upaya transformasi digital, ITS tengah mengembangkan platform berbasis teknologi cerdas, My ITS, My IT Solution, yang berupa aplikasi berbasis web dan mobile yang terintegrasi untuk melayani seluruh pemangku kepentingan. Semangat baru, sistem baru, dan strategi yang akan diterapkan ITS diharapkan dapat menjadikan formula baru untuk mewujudkan excellent services. Memberikan layanan prima adalah moto yang harus dipegang oleh Sivitas Akademika ITS sebagai komitmen untuk selalu siap melayani dan memberikan layanan yang terbaik di setiap kesempatan. Tidak hanya menghasilkan publikasi ilmiah internasional, tetapi juga melakukan hilirisasi produk riset sebagai sumbangsih kepada bangsa dan peradaban dunia. ITS bertekad menghasilkan lulusan berkelas dunia dari berbagai jenjang pendidikan yang siap bersaing di era industri 4.0, baik sebagai tenaga profesional ataupun wirausaha di berbagai bidang usaha. Kolaborasi dan integritas adalah kunci dalam perjuangan meraih mimpi ITS agar dapat berkontribusi dalam kemandirian bangsa, menjadi rujukan perguruan tinggi Tridharma, berinovasi untuk menunjang industri dan kelautan. Sekali lagi, terima kasih atas dukungan seluruh Sivitas Akademika, seluruh kolega, pimpinan ITS di berbagai level, tenaga kependidikan, tenaga penunjang, dan seluruh mahasiswa. Semoga ITS Entrepreneurial University segera kita raih. ITS berupaya memperbaiki diri dalam tata kelola, baik administrasi akademik, keuangan, SDM, dan kemahasiswaan. Transformasi digital untuk meningkatkan digital capability dan membuat semua komponen menjadi connected, penyempurnaan infrastruktur digital, dan integrasi sistem informasi keuangan, akademik, SDM, dan kemahasiswaan menjadi terintegrasi. Transformasi digital ini akan memudahkan karena terbaca dalam berbagai platform aplikasi digital yang bisa diakses melalui telepon pintar. Penyederhanaan sistem pertanggungjawaban keuangan lebih efisien transparan, namun tetap compliance diharapkan mampu mempermudah administrasi birokrasi. Sebagai perguruan tinggi yang berbasis riset dan inovasi, ITS senantiasa akan selalu memperbaiki lingkungan akademik, dimulai dari lingkungan terkecil hingga laboratorium dan fasilitas pendukung lain. Cita-cita ITS untuk menjadi Center of Collaborative Research and Innovation diwujudkan melalui pembangunan Science Technopark yang terdiri dari Maritime Center, Robotics Center, Automotive Center, dan Creative Center. Sebagai wujud ITS Smart Eco Campus yang peduli dengan lingkungan, ITS akan memperindah wajah kampus melalui penanaman bunga tabebuya di sekitar wilayah kampus ITS. Pengembangan dan penyempurnaan fasilitas pendukung akademik berupa Smart Classroom diharapkan dapat mengiringi langkah ITS sebagai Research and Innovation University. Untuk meningkatkan kemampuan hasil riset, prestasi, dan publikasi, ITS terus mengembangkan laboratorium riset maupun inovasi yang hingga kini telah mencapai 180 laboratorium.
Banyak menu yang tiba-tiba terkenal, mulai dari odading hingga bakmi. Ada apa di balik kompor?
Institut Teknologi 10 November tak henti-hentinya membantu masyarakat dalam mengatasi coronavirus disease 19. Salah satunya dengan membentuk Satuan Tugas COVID-19 ITS. Berbagai bentuk nyata telah dilakukan. Berikut perjalanan Satgas COVID-19 ITS. ITS bekerja sama dengan RSUA dalam riset pembuatan portable disinfektan. Selain itu, ITS juga melakukan pendistribusian makanan bagi mahasiswa yang masih berada di Surabaya. ITS bersama mahasiswa melakukan penyemprotan disinfektan ke 250 rumah di kampung Surabaya. Tak kalah menarik, ITS juga membuat disinfektan chamber yang bekerja dengan menggunakan ozon. Medical Center ITS juga turut dijadikan garda depan selama COVID-19. Dalam mengatasi keterbatasan face shield, ITS membuat serta mendistribusikan 70.000 face shield. ITS mengadakan program pulang kampung mahasiswa sebagai wujud kepedulian. Tidak hanya itu, ITS bersama RS Universitas Erlangga dan RSUD Dr. Sutomo membuat low-cost ventilator yang akan digunakan untuk kedua rumah sakit tersebut. Selain low-cost ventilator, ITS produksi massal hand sanitizer yang didistribusikan ke fasilitas pelayanan kesehatan. Ketinggalan, ITS bersama dengan RS Universitas Erlangga melakukan pelauncingan robot pintar Raisa. ITS dukung APD Medical Center guna tambah kesiapan sebagai penyedia layanan pertama. Penuhi nutrisi masyarakat selama masa pandemik, ITS produksi sayur organik. ITS juga membuat violeta dan lampu UV guna sterilisasi ruangan tanpa harus mengeluarkan orang dari dalam ruangan tersebut. ITS bersama alumni membuat alat pelindung diri hazmat suit. Inovasi lain ditunjuk ITS dalam pembuatan bilik tes swab COVID-19 hasil kolaborasi dengan Universitas Erlangga. ITS juga melakukan launching robot pintar Raisa ICU dan HCU. Dan yang tak kalah penting, ITS melakukan baksos donasi bagi para pekerja dan masyarakat membutuhkan di masa pandemik ini. Kebaikan tak terukur oleh jarak, dan jangan biarkan hal ini berhenti di kamu. Tebar senyuman halau rintangan untuk perangi COVID-19. Terima kasih pahlawan.
Hari ke hari, persebaran pandemi COVID-19 di Indonesia kian meluas. Fasilitas kesehatan publik yakni rumah sakit terus alami kenaikan jumlah pasien dalam pantauan tiap harinya. Dan secara tidak langsung, fasilitas kesehatan tersebut juga dapat menjadi ladang yang luas bagi persebaran dan pertumbuhan mikroorganisme. Oleh karena itu, Institut Teknologi 10 November berkolaborasi dengan Universitas Erlangga menciptakan robot ultraviolet yang dinamakan Violeta. Penggunaan sinar ultraviolet atau UV dinyatakan lebih efektif untuk sterilisasi ruangan dibanding dengan penggunaan disinfektan yang masih meninggalkan residu kimia setelahnya. Diharapkan dengan adanya robot Violeta dapat memudahkan proses sterilisasi ruangan untuk perawatan pasien COVID-19. Demi menghindari kontak fisik, robot ini dirancang untuk dikendalikan dari jarak jauh dengan basis wireless control dengan jangkauan waktu 10 hingga 15 menit untuk beroperasi pada jarak 1-2 meter dari objek. Robot ini nantinya dapat beroperasi selama 4-6 jam pada keadaan ruangan yang telah dikosongkan.
Terima kasih atas percobaan Violeta yang sangat spektakuler. Alat sterilisasi dengan cara robotika sangat bagus sekali, sangat representatif dan betul-betul teknologi yang sangat modern banget. Semoga memang bermanfaat sekali untuk rumah sakit karena dengan adanya COVID-19 pandemi ini, maka ruang sterilisasi untuk bedah, untuk ruang anestesi, Maka supaya meminimalisir daripada kontak penularan dengan robotika ini, sistem robot maka akan lebih mudah dan lebih aman.
Untuk sementara ini, robot Violeta hanya dapat diberikan pada Rumah Sakit Universitas Erlangga setelah dilakukan uji mikrobial di Laboratorium Departemen Biologi ITS. Surabaya, Tim ITS TV melaporkan.
Especially anak muda, di mana mereka supaya nggak menyerah dalam kondisi apapun. Ada ombak gede, di situ ada peluang.
Selamat datang di perpaduan kesegaran dari rumah Ramen Girl.
Ramen Girl!
Ya, itu dia. Sejak pandemi dia cuma bisa di rumah. Makan, kerja, sampai shopping juga dari rumah. Dia jadi nggak fresh di rumah.
Wait a minute, gue bisa tetap segar kali di rumah. Ya kan ada Fresh Tea, paduan daun teh berkualitas dan bahan alaminya. Jadi inspirasi gue buat maduin musik sama ilustrasi komik untuk nemuin kesegaran baru di rumah.
Oke, siap segar di rumah bareng Fresh Tea.
Di tengah pandemi COVID-19 yang sedang terjadi, salah satu profesi yang menjadi sorotan adalah para tenaga kesehatan. Bagaimana tidak, tenaga kesehatan atau yang disingkat nakes berada di garis terdepan dalam penanganan wabah ini. Dengan jumlah pasien yang terus bertambah, mau tak mau, para nakes harus siap sedia berjaga di rumah sakit. Ironisnya, tak sedikit nakes yang akhirnya justru tertular virus corona dari pasien yang dirawatnya. Hal ini berkaitan erat dengan frekuensi kontak dengan pasien yang bisa terjadi tiap hari dan meningkatkan probabilitas para nakes terjangkit COVID-19. Melihat keadaan ini, ITS kembali melakukan inovasi teknologi terbaru. Penasaran dengan inovasinya? Berikut liputan selengkapnya. Pada hari Selasa, 14 April 2020, ITS mengadakan launching perdana Raisa atau Robot Medical Assistant ITS Erlangga. Launching Raisa yang bertempat di Gedung Robotika ITS ini dihadiri oleh beberapa pejabat ITS dan RSUA seperti Rektor ITS Profesor Asari, Direktur RSUA Profesor Nasruddin, Ketua MUA ITS sekaligus mantan Menteri Pendidikan Profesor Nuh, dan bahkan Wakil Gubernur Jawa Timur Emil Dardak. Raisa dikembangkan oleh tim profesional ITS dan anggota tim robotik ITS yang telah memenangkan penghargaan internasional. Menurut Profesor Nasruddin, tenaga kesehatan dari RSUA juga butuh aplikasi teknologi yang dimiliki oleh ITS. Raisa memiliki satu layar interface yang dapat menghubungkan pasien dan perawat. Layar interface ini berguna untuk mempertahankan aspek sosial dan diharapkan tetap dapat membantu psikologis pasien walau tidak berhadapan langsung dengan perawat. Di bawah monitor layar interface terdapat 4 tingkat rak yang dapat menampung beban hingga 50 kg. Rak-rak tersebut nantinya akan membawa berbagai kebutuhan pasien terjangkit COVID-19 seperti makanan, pakaian, dan lain-lain. Robot ini dikendalikan dengan joystick dari jarak jauh yang tersambung via Wi-Fi dan normalnya dapat beroperasi selama 8 hingga 10 jam. Disampaikan pula bahwa Raisa merupakan gabungan dari teknologi 4 tim robotik ITS, yaitu Ichiro, Iris, Barunastra, dan KRI. Robot ini diperkirakan akan dibanderol dengan harga Rp100 juta per unitnya.
Satu produk yang sudah jadi, tapi pasti perlu penyempurnaan. Nah, disitulah kemudian dengan kita mensupport fundingnya untuk alat, bukan untuk meriset, tapi untuk mulai menggunakan dan menyempurnakan hasil penelitian. Karena tahap itu yang tahap penting sekali sebenarnya.
Assalamualaikum warahmatullahi wabarakatuh. Hello ladies.
Halo,
Pak Akam, I can hear your voice. Oh.
Assalamualaikum Prof. Basuki.
Yes, hello, Pak Abadi. How do you do today?
Very good.
Are you fine? Okay, thank you. Hello, everybody.
Where is Pak Akam?
I think his connection's not stable. Yeah, probably we can ask to Pak Subhan. Maybe he knows.
Yeah, the time is ticking.
Halo, Pak Subhan.
Sama Dewi bisa. Masih Pak.
Tepung ini. Waalaikumsalam. Ya. Anu, tak dekat.
Hello, ladies and gentlemen. Welcome to parallel session of Icompac 2020. Let me introduce. My name is Revi. Will accompany you as assistant moderator for this session. There will 11 presenters and I will explain the rules of this session. Rules 1. Presenters will share their video presentation at most 10 minutes. If we find any trouble like connections, we can help to play the videos. 2. Presenters will answer at most 2 questions that moderator choose in 5 minutes. 3. For participants, they can give question during the presentation on the given link. The question link will share in the Zoom chat room. Number 4, during presentation, all participants should be in mute mode and turn on the video. Now, let's start for the first presenter. For the detailed mathematical model of Zika disease by considering transition from the asymptotic to symptomatic phase. The authors is Dipo Aldila, Karamina Rashika, Gianina Ardaneswari, and Hengki Tasman.
Can I share the screen now?
Yes.
Can I share the screen now? Wait.
I'm sorry, Ibu Karamina.
Yes.
We don't hear the sound yet. Maybe you
Uh,
can share sound.
how can I share the sound of
Yeah,
this video?
you need share computer sound in option.
Which one?
Yeah, or maybe Mbak Revi, you can play the video.
Oh yeah. Thank you. Sorry.
Okay.
Okay, I can start share screen. Yes, sure.
You have the video, Mbak Revi? Video from Bukan Ramina. Yeah, please, you can play the video. Aku ya soalnya mas.
Sorry, but it is still muted.
Model Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Karamina Rashka from Department of Mathematics, Universitas Indonesia. Today, I would like to share with you about a mathematical model of Zika disease by considering transition from the asymptomatic to symptomatic phase. My talk today is divided into 5 main sections, starting from introduction, model construction, model analysis, numerical simulation, and conclusion. Now let's begin with introduction. So, what is Zika? How is this disease transmitted, and what are the symptoms? The following slide is to answer these questions. In general, Zika disease is an infectious disease which infection is caused by Zika virus or ZIKV. ZIKV itself belongs to the Flavivirus genus and the Flaviviridae family. There are many ways Zika disease can be transmitted, but primarily Zika is transmitted by mosquito. Zika also can be transmitted through human contact, such as from mother to her fetus during pregnancy, sexual contact, and blood transfusion. The symptoms of this disease are conjunctivitis, fever, rash, headache, joint, and muscle pain. The incubation period lasts for 3 till 14 days, while the symptoms last for 2 till 7 days, but most cases develop no symptoms. In this work, we consider there is transition from the asymptomatic to symptomatic phase on the model. Therefore, we need some facts to support this idea. First, in some diseases, there are asymptomatic individuals who develop symptoms later on. Second one, Sakas et al. 2018 found a Zika transmission case through sexual contact from an individual who had no symptoms. Lastly, Chisholm et al. Constructed a model considering individual transition from asymptomatic to symptomatic. Based on the introduction that I have stated, there are some issues that being addressed in this work, such as how is the model constructed, and how to analyze the existence and stability of its equilibrium points, how is the interpretation of the analytical studies and numerical simulations result. Last but not least, does the transition rate of human from asymptomatic to symptomatic phase have any impact to the model? To answer these questions, first, let's move on to the model construction. This model involves two populations, human and mosquito. We divide human into 5 compartments and mosquito into 2 compartments. The number of each population will increase due to birth, and each compartment will decrease due to death. Susceptible human and mosquito will get infected due to human or mosquito to human contact. The exposed human will become infected once the incubation period meets an end. The infected human can get treatment and get to be recovered. As stated before, in this model, we consider transition rate from the asymptomatic to symptomatic phase. So we add an arrow that represents human transition from asymptomatic to symptomatic phase. And this is the table of parameters that are being used in the model. Based on the explanation about the model construction and the table of parameters that has been shown, now we can construct a Zika transmission diagram using a mathematical notation as can be seen on this slide. Lastly, from the diagram, we can also form the differential equation of this Zika mathematical model in equation 1 as shown on the slide. After the model construction, the next thing I'll share with you is model analysis. But before we go any further, since the model must be biologically interpretable, let's take a look at the basic properties of the model. Given the initial condition is non-negative for each compartment, then the solution of system 1 is non-negative and bounded for every t greater than or equal to 0. As a direct consequence of this statement, we can construct a positively invariant region that is Next, non-dimensionalization. The process of non-dimensionalization is carried out by using the transformations of variables and parameters as follows. The non-dimensionalization form of model 1 is written in equation 5. Note that system 1 consists of 7 variables and 12 parameters, but through the non-dimensionalization
I think Mbak Rifa disconnect. Maybe I will download again the video. Open pakai apa, Mas?
I'm sorry for the connection. Can I play again the video?
Yeah. Please, Mbak Revi.
After that, we have basic reproduction number or R0 to represent the average number of secondary infection. For this model, the R0 is stated in theorem 3.2. Now let's turn into disease-free equilibrium that in this paper is denoted as E0, as can be seen on the slide. Since E0 consists of non-negative numbers, then E0 always exists without condition. The stability of DFE in this model is obtained by using the method by Van den Driest 2002, and the result is the DFE is locally asymptotically stable if R0 less than unity. For endemic equilibrium in this model is denoted by E1 as shown on the slide. The Zika model given by system 5 has one unique endemic equilibrium if R0 greater than 1 and no endemic equilibrium otherwise. The stability of endemic equilibrium in this model is obtained by using central manifold theorem, which the result is written in theorem 3.6. Based on this result, we also get the information that in this model there occurs forward bifurcation when R0 equals to 1. Let's see the illustration on the slide. From the illustration, we also can see that when R0 equals to 1, there occurs the change of stability of the disease-free equilibrium with the existence and local stability of endemic equilibrium. Now let me show you the result of the numerical simulation of this model. These are the value of parameter. Note that simulations are performed using non-dimensionalized model. So the parameters that are being used are the non-dimensional one. This is the first result. The table shows the result of Arnold elasticity analysis. This analysis is conducted to see how significant the parameters affect the model. Based on the result, if Arnold is greater than 1, gamma becomes the most significant parameter to the model. Meanwhile, if Arnold less than 1, beta H1 and beta H2 are the most significant one. Now let's take a look at the autonomous simulation to see how the changes in some parameters affect the model. The first one is beta H1 and gamma. The result shows that for any certain rate of infection from mosquito to human that is followed by the increase of the recovery rate, then the value of Arnold will constantly decrease until it is less than 1 and the population will be free from Zika disease. The second one is alpha. The analytical and numerical result shows that alpha really has impact to the model. The greater the value of alpha will decrease the value of Arnold, which adds up to the disappearance of Zika in the population over time. Lastly, beta H2. As can be seen on the result, the lower the infection rate among human results in the proportion of infected human and mosquito to decrease. It will affect to the size of Arnold that will also constantly decrease and Zika disease disappear over time. In summary, a mathematical model of Zika disease by considering transition from the asymptomatic to symptomatic phase has successfully been constructed, involving two populations, human and mosquito. This model has two equilibrium points, disease-free and endemic equilibrium. In this model also occurs forward bifurcation when Arnold equals to 1. The elasticity analysis on Arnold shows that the recovery rate is the most significant parameter in determining Arnold when it is less than unity, and transmission rate when Arnold larger than unity. Alpha does have impact to the model, but it is less sensitive to determine the size of Arnold. The sign of its sensitivity is negative, so the increase of alpha will decrease Arnold. It is possibly because the lesser the number of asymptomatic individuals, the easier to trace the infection in the community. These are the references that are being used to discuss about this topic. That's all from me. Thank you for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Mbak Revi, maybe I will continue the discussion for this session. Yeah.
Yes, Pak.
Okay. Thank you for presentation from Bu Karamina. Now, discussion session. Maybe there are a question. There are questions from other presenters. You can raise hand or maybe by chat. Maybe from me, Bu Karamina, I'd like to what the tools you use to simulate your model.
To do the simulation of this model, we use Maple for the model analysis and for the analytical model, for the analytical one, and then for the numerical simulation, we do that by using MATLAB.
Oh, okay. So from Maple, you have the solution from the system differential equation, or
yes, until the result itself, it can be seen on the numerical simulation also.
Okay. Thank you. From Besia Raisna,
Yes.
please.
Yes. Why did you do the simulation for parameter alpha? Is parameter alpha controllable?
Okay, for that question, we did the simulation for alpha is because we want to know whether alpha does really have impact to the model or not, and how it also affects the model. And then for alpha is controllable or not, we consider things that are that affect the value of alpha are immunity and the virus itself. So for this model, the value of alpha is not controllable.
Thank you, Karamina.
Thank you.
There are question again from other presenters. Maybe if we can continue to next presenter.
Thank you.
Okay, thank you, Bu Karamina. And then for the next presenter, siapa yang aku lupa jadwalnya. I'm sorry, I found oh yeah. To the paper with the title Backward Bifurcation Analysis on Tuberculosis Disease Transmission with Saturated Treatment. Might be with the author. Please, time is yours.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hello ladies and gentlemen. Before starting the presentation, please allow me to introduce myself. My name is Besia Raisna Saslia. Today, I will present our paper with the title Backward Bifurcation Analysis on Tuberculosis Disease Transmission with Saturated Treatment. This is outline of the presentation. First is introduction, second is model construction, third is model analysis, fourth is simulation of the model, five is conclusion. Tuberculosis disease is an infectious disease caused by Mycobacterium tuberculosis. Tuberculosis frequently attacks lung and spread through cold or direct contact with an infected individual. There are two different types of tuberculosis: latent tuberculosis infection and active tuberculosis disease. The latency period of tuberculosis needs several years, which make tuberculosis categorized as a slow infection disease. Because of the long term of latency period, individuals may conduct reinfection. Tuberculosis treatment need to isolate the infected individual from general social contact with susceptible population, which make a medical research become so limited, such as for isolation room, number of beds in the hospital, etc. Recently, Baba introduced a simple SEI, susceptible exposed infected model with a saturated infection rate. In this paper, we modified the SEI model introduced by Baba by considering the limitation of medical research. Modification of the models lies in the modification of the treatment rate. Therefore, this is the construction of the model. The model based on susceptible individuals increased due to newborn. Susceptible, exposed, and infected individuals decreased due to natural death. Exposed individuals increased due to slow infection by susceptible individuals. Infected individuals increased due to fast infection by susceptible individuals. Exposed individuals decrease caused by progression to be active tuberculosis, and the last is infected individuals recovery. Description of it will be this transmission diagram. From this transmission diagram, we get the mathematical model. Before we proceed to analyze the well-posed criteria of our model and further analyzing the bifurcation phenomena, we will do a non-dimensionalization. The process of non-dimensionalization is carried out by using the transformation of variables and parameters as follows. The non-dimensionalization model is the number of variables and parameters in the model is reduced from 3 variables to 2 variables and from 8 parameters to 6 parameters, and all the variables and parameters involved have no dimensions. To make the non-dimensional version of tuberculosis model to be meaningful, we will show that the model has a non-negative solution more than 0. Field, since the initial condition is non-negative, and then we have that all solutions of x2 and x3 from system 4 are always positive, we have lemma 1 and lemma 2. Next is basic reproduction number, or R0. Using the next generation matrix approach, the basic reproduction number of system 4 is given by Next, the disease free of equilibrium of tuberculosis model is epsilon 0. By linearizing system 4, we have lemma 3. After that is endemic equilibrium. The endemic equilibrium of tuberculosis model is epsilon dagger, where this is the x2 star and x3 star is taken from the positive root of quadratic equation given by equation 10. Since equation 10 is quadratic, we have that system 4 has 3 points. Since B2 less than 0 and B0 more than 0, we have the following lemma in lemma 4. System 4 always has a unique endemic equilibrium point if basic reproduction number more than 1. Next is existence of backward bifurcation. We explore the phenomena of backward bifurcation of system 4 using the center manifold theorem. The result is written in theorem 1. That this is the backward bifurcation diagram. For all initial conditions in the first flow, when R0 less than Rc, then the disease-free equilibrium is stable. When R0 equal 1, hysteresis occurs, which followed with a new large endemic equilibrium. On the other hand, the endemic equilibrium remains stable until it reaches R0 equal Rc and jump from stable endemic equilibrium into a new stable disease-free equilibrium. The next is local sensitivity analysis of bifurcation parameter. From table, we know that the saturation parameters A and B do not affect the size of R0. The increase of alpha, P, and beta will increase R0, and the increase of gamma will decrease value of R0. For example, increases value of beta by 10% will increase value of R0 1%. Next is simulation of TB model. When A less than 8.64, backward bifurcation do not occur, and since R0 less than 1, we have the blue curve tends to the disease-free equilibrium epsilon 0. When A more than 8.64, backward bifurcation occur, which lead to a stable endemic equilibrium, or red curve, even though R0 less than 1. Blue curves show the dynamic of population tend to the disease-free equilibrium, while the red curve tends to the endemic equilibrium. And the conclusion is, in this paper, we modified the tuberculosis model introduced by Baba. By considering the treatment rate as a saturated treatment function, the non-dimensionalization process allows us to reduce the complexity of our model and make all parameters and variables become non-dimensional. Second, this model has two equilibrium points, disease-free equilibriums and endemic equilibrium. We find that the tuberculosis-free equilibrium point is locally asymptotically stable if R0 less than 1 and unstable otherwise. And the last is backward bifurcation, which different from saturated treatment parameter tuberculosis eradication program become more difficult since the endemic equilibrium may still exist even R0 less than 1. Small change of infection parameter beta may lead the system from stable tuberculosis-free equilibrium point into jump new large endemic equilibrium point. Okay, I think that's all. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Bu Besya Raisna Saris Taslia, for the great video presentation. So we discussion session, maybe there are questions for Bu Besya.
Akam,
Yeah.
I have a question.
Yeah. Please.
Okay, Mbak Pesha, is there any particular reason for using saturated, what is that, infection?
Sorry, can you repeat
Is there
your
any particular
question?
reason for using the saturation infection?
Saturating infection in model already using in previous paper. In this paper, I using saturated treatment rate.
Yeah, but is there any biological reason for using the function?
Okay, wait. Oh, for the function for saturating infection, we choose the function. We choose.
But is there any particular reason? Is there biological motivation using the saturation there?
In so I using the saturation treatment rate because wait for a minute.
Or maybe do you wanna answer it in bahasa to clear the answer
Can
from?
I answer with bahasa?
Yeah. How about that for all presenters?
It's okay.
Okay. Okay. Bu Bisya, please
Okay, ya.
you can
Jadi
continue your
pertanyaannya itu kenapa kita pakai fungsi saturasi di model saya kan?
Betul.
Ya, karena di penyakit tuberkulosis ini kenyataannya kan sembuhnya itu lama. Jadi dan juga ada tuberkulosis yang tidak bergejala, laten tuberkulosis. Nah, jadi tuberkulosis itu penyakitnya bisa lama di dalam tubuh. Nah, karena itu penyakit tuberkulosis ini pengobatannya pun harus rutin. Jadi semakin banyak manusia yang terinfeksi tuberkulosis, semakin terbatas pula tenaga sumber daya medis di rumah sakit. Seperti misalkan ruang isolasinya jadi terbatas karena beberapa pasien harus diisolasi demi menjaga interaksi antar individu yang terinfeksi dan yang tidak terinfeksi agar penyakit tersebut tidak menular, atau dokter-dokter bedah paru juga. Jadi karena di dunia nyata itu semakin banyak individu yang terinfeksi, maka semakin terbatas ruang untuk mengobati individu tersebut. Makanya kita memakai fungsi saturasi untuk pengobatan gitu.
Oke. Boleh nanya lagi Pak Akam?
Yeah, please.
Oke, terus tadi yang backwards clarification-nya tadi itu kalau diinterpretasikan secara biologi gimana?
Kalau diinterpretasikan secara biologi, jadi yang backward bifurkasi itu kan dia mundur ke belakang kan. Jadi yang tadinya angka bebas penyakitnya itu stabil, tiba-tiba dia ada loncatan yang tinggi untuk angka endemic equilibrium-nya. Jadi wait. Kayaknya share screen.
Or maybe because we have the limited time, you can make contact with Bapak Hadi Susanto.
Oke, oke.
How about that, Pak Hadi? I'm sorry because we have the limited time.
Ya, saran saja nanti mungkin bisa didiskusikan dengan supervisornya,
Iya.
dengan Pak Dipo. Nggak tahu apakah backwards verification itu istilah yang umum, tapi kelihatannya sih kalau dari dynamical system sebenarnya disebutnya subcritical verification.
Iya, oke.
Terima kasih.
Terima kasih Bapak Hadi.
Thank you, Pak Hadi. So we can continue the next presenter. Yeah. Maybe you can close your presentation, Bu Pesia.
Thank you.
Okay. For the next presenter, the paper with the title "The Improvement of Visual Object Tracking Using Combination Approach" by Yabunaya Habibi and Muniri. Please, time is yours. I'm sorry, Yabunaya. We still can't hear your computer sound. Maybe you can share your computer sound. Or maybe we can help you to play your video presentation. Hello, Mr. Yabunaya. Or maybe Muniri. can we play your video presentation? Ya Bunaya Habibi.
I think he has a trouble.
Okay, okay. I will play the video presentation from Ya Bunaya Habibi.
Assalamualaikum warahmatullahi wabarakatuh. In this video, I will present my paper on visual object tracking that is entitled The Improvement of Visual Object Tracking Using a Combination Between Particle and Correlation Filter. Visual object tracking is the process of detecting a moving object or multiple objects over time using a camera or video such as its many application in robotics, navigation supervision, human computer interaction, and automation. We can get image sequence for our video to analyze frame by frame. In general, object tracking runs based on initialization described earlier. Then, the task is estimating object motion in an image sequence, with the hope where each object in an image can be tracked precisely. Robust object tracking is a challenge in computer vision field, even though some studies have proposed tracking approach for a last time, but there are still many things that need to be developed for overcome various tracking problems. Meanwhile, the task to build a novel approach which efficiently handle all tracking problems still in development step, especially supported by computation time. From the complex tasks in visual object tracking, so we try combine two approaches, namely adaptive particle filter and discriminative correlation filter, to overcome more complex tracking problem as an effort to improve overall tracking accuracy. However, this build make a double-edged knife where the utilization of two approaches together will make a large computation time. So, we also utilize sleep tracking as an alternative solution to reduce high computation time to increase tracker speed without reducing accuracy and avoid identification error. We apply adaptive particle filter by Huang Yu's article, where each particle represents the central candidate objects by xt with xy, which correspond to the weight of the particle. We can determine xt for weight average of all particle. Mixture model from adaptive particle filter, useful for overcome visual disturbance condition, motion continuity of the object, trajectory smoothness, and especially in this red color, we can predicting the object position in occlusion or object motion which are detected. So, from this statement, our combination employs adaptive particle filter as the main framework and embed discriminative correlation filter in it to estimate motion vector. In adaptive particle filter, first, generate a number of particles as represent the central candidate. The motion of object can be detected in estimation. The reliability of the particle depends on the effectiveness of the observation model of particle weights, where in Huang using measurement for observation, namely intensity measurement, motion measurement, and trajectory measurement. If object motion can be detected, particle will be updated by intensity and motion measurement. and it can adjust if the object is not detected by prediction with a projection and interpolation, and particle will be updated by trajectory and motion measurement. We use discriminative correlation filter by Daniel Jan, where the baseline is closely related to the motion tracker by Bolme. This approach estimates object motion for translation and scale independently. So this effort provides improved performance while being computationally efficient. In this illustration, first starting from image sequence of video and initialization of object, then estimating in frame T and description of visual feature of the content in image by extract feature. And in filter process, input of image has been changed in Fourier transform or frequency domain. And to get optimized object position, the result of the filter in inverse fast Fourier transform to be a reference to get optimized object position by spectrum peak position in spatial domain. Then, update filter from this process in frame T as reference in next frame for object estimate with updated filter. So, from above, we have ordinary adaptive particle filter as follows. And if we embed motion estimation by discriminative correlation filter, we have this block diagram. In general, object tracking process through frame by frame sequentially, as it runs in each frame of image sequence. But we purpose leap tracking for efficient computation time, so we can leap frame in 1 frame, 2 frame, 3 frame or more. The number of leap frame depend on the object condition, where we have consideration that more leap frame will risk to reduce accuracy. So we will leap frame adjust object condition. Meanwhile, in the leap frame the object position we predicted in this case to adjust the prediction model of the adaptive particle filter which has reviewed above. In distance precision, we observe tracker accuracy in percentage of Euclid's distance or the extent how far the estimate deviates from the true object location. From this, we can average Euclid's distance in each frame of image sequence to get percentage of distance precision. In general, this evaluation is useful for the scale estimation of the object contained in the bounding box according to the true object. In shader location error, we observe tracker accuracy in percentage of how far the estimate deviates from the true object location with Euclid distance. Different from distance precision, we not average Euclid's distance, but we add estimates deviates from the true object location frame by frame to get percentage of distance precision. In this evaluation, we can observe computation time based on time required from tracker to complete the task, especially in a video. If tracker have more frame rate in FPS, so tracker more fast to process per frame video. Although tracker speeds depend on object size, frame resolution, or shot area and other. We show result from testing by our combination to 15 benchmark tracking dataset in overlap precision, distance precision, and center location error. In this table, we separate result from testing become 3 groups. First group, which is marked in blue color, with 3 testing datasets, have similarity between the test result from discriminative correlation filter with our combination approach in computation time, because in this group we cannot use leap tracking for reduced computation time. Second group, which is marked in red color with 4 testing dataset, cannot use leap tracking, so test result have higher computation time. But there are several image sequences which tracked with better accuracy. And group in black color with Ike testing dataset is the best of test result from besides having better accuracy but also having a lower computation time. In this picture, we show result of 2 tracker testing by our combination and discriminative correlation filter in distance precision and overlap precision by average from each group blue mark, red mark, and black mark. And we can see that in red color show performance of our combination with discriminative correlation filter. That percentage show difference average of accuracy between our combination with discriminative correlation filter. And this slide, we can see performance of our combination with discriminative correlation filter in central location error and frame per second. Black group or black mark show the best result where in that tracking a dataset of image sequence. Tracker have more accurate from locating object and less computation time as a help in object tracking. And this picture show comparison of computation time if we apply leap tracking. We can get low computation time proportional to a number of leap frame. The test of our combination use 15 benchmark with various tracking problems, and so our combination significantly increased the accuracy of the tracker in central location error, overlap precision, and distance precision. And we can improve tracking speeds without reducing accuracy. And thank you very much for all of attention. Wassalamualaikum warahmatullahi wabarakatuh.
Yeah, thank you for Mr. Bunaya. So we can discussion. Maybe there are question from other presenter. Okay, maybe from me for Mr. Yapunaya. So maybe you can explain. I still understand about overlap. Maybe you can explain again, mungkin MIP.
Overlap.
Yeah. I'm sorry, we can hear your voice. We can hear your voice.
Unmute.
Maybe you can speak with speaker, not with headset. So maybe this voice more clear. I still can't hear your voice, Mr. Yabunaya. Maybe the other participant, have you hear the voice from Yabunaya? Or maybe he has disconnected, or there are problem with their network. So we can continue the next presenter, maybe. The next presenter, the paper by title Determine the Basic Reproduction Number Using Transition Intensities Multi-State SERD Model for COVID-19 in Indonesia by Faihatus Zaharia, Dedi Rosadi, and Aditya Roni Effendi. Please, time is yours.
Okay, thank you.
I'm sorry, Bu Faihatus, we can hear the sound of your video. Maybe you can share your computer sound.
There are several outlines.
Bu Faihatus.
Yes.
Yeah, we can still can't hear the sound from your video.
Oh. Okay.
Yeah, maybe you can share your computer sound so we can hear your video sound.
Okay.
Oh yeah.
Okay, thanks.
I'm sorry, Bu Faihatus, still cannot hear your voice. Or maybe we can play your video.
Okay.
Okay. I will play your video presentation.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity to me to present my paper entitled Determination of Basic Reproduction Numbers Using Transition Intensities Multi-State SIR Model for COVID-19 in Indonesia. Previously, my name is Faihatul Zuhairo. I am from STKIP PUP Makassar, and now I am continuing my doctoral study at Universitas Gadjah Mada. I'm the first author in this article, and second author, my supervisor, Professor Didi Rosadi, and the co-supervisor, Mr. Aditya Roni Effendi. So, let's get started. There are several outlines that I will present in this presentation, namely, the first, introduction, the second, material and method, and then result, and the last, conclusion. Introduction. Research on multi-step model in epidemiology has been carried out before by Login et al. About HIV infection, Klein and Xu about bone marrow transplantation, Meyer and Schumacher about breast cancer, and Zhang et al. About Alzheimer's disease. While research on COVID-19 has also been carried out with various models, namely SIR model by Batos and Kajuiro, SIRD model by Chang et al., SEIARD model by De Leon, and Richard model by Zuhairo and Rosadi. In epidemiology, it is inseparable with the term basic reproduction number, which is the average number of susceptible individuals infected directly by other infected individuals in a population that is still vulnerable. Thus, R0 contains information on the spread of the infection disease outbreak. If R0 less than 1 indicate that the infection disease will eventually stop epidemic and even disappear by itself. However, if R0 more than 1 indicate that the number of infected individuals will continue to increase until it reaches its equilibrium point. For the determination of R0 using the new transition intensity study by Oroway in 2015, which was applied to case of HIV/AIDS. Then, in this article, the author applied the calculation of R0 by using the transition intensity with the next generation matrix method in the case of COVID-19 in Indonesia. Material and method. The data used in this paper is COVID-19 data in Indonesia from March to July 2020, taken from BNPB. The data used consists of the number of Indonesians who were infected, the number who recovered, and the number who died in this time frame, either due to COVID-19 or die to the other reason. Data regarding the number of individuals who die were taken from macro trends and worldometers. It also requires data on the length of time a patient is start until health and the length of the patient being treated until death. Assumption of constant transition intensity means that the number of transition from one state and another per time until doesn't depend on the initial time, depend only the time interval. So the Markov chain used is a homogeneous time Markov chain. In observation, we observe and time and type of each transition made by each individual, assuming the intensity of the transition is constant. It results in the time spent in each state having an exponential distribution. In calculation R0, we use the next generation matrix method. COVID-19 transition model and parameters used. In this model, use S, E, R, and D. The first, ST, the population of vulnerable individual infected with COVID-19 will be the population of individual infected with COVID-19. The population of vulnerable individual increase due to individual recovering from the COVID-19 but doesn't have immunity to COVID-19 and decrease due to individual infected with COVID-19. And the second, IT, the population of infected individuals, increase the population infected with COVID-19 due to vulnerable individuals who come in direct contact with sufferers of COVID-19, the decreased population of infected individuals due to individual recovering due to natural immunity and individuals who die from COVID-19. And then RT, individual who recover and are not immune to the coronavirus. So the population increase from infected individual who recover and decrease because individual who recover from COVID-19 don't have immunity to the coronavirus, so they will become vulnerable individuals again. And the last, DT, the population of individual who died, here only came from death because by COVID-19, where ST, IT, RT, and DT are the state of the model form. So ST plus IT plus RT plus DT equal to N. Multi-state model for COVID-19. In multi-state modeling, in the case of COVID-19, to model the intensity of the transition using 4 states, namely susceptible to infected, mu 1, 2, infected to recover, mu mu23 infected to death, mu24 recover to susceptible, mu31 and susceptible to death, mu14. By using the Chapman-Kolmogorov equation, a transition intensity matrix like this is obtained. Matrix P is transition probability and matrix Q is transition intensity. The first result about estimate of the transition intensities, the estimator for mu ij equal to Nij division by Ti. Estimated result obtained as follow: mu12 is 0.008723 until mu31 0.3. The second result, basic reproduction number. To calculate R0, we only use the infected state, so the Q matrix can be performed into matrix J. And the result R0 equal to 1.079708. The last result about reproduction number using several methods. The result of the recalculation of reproduction number using exponential growth rate, maximum likelihood, and attack rate. The estimation result of all methods show approximate value. Conclusion. The spread of COVID-19 in Indonesia can be modeled using a multi-state model with 4 states, namely susceptible, infected, recovered, and dead. Then, using COVID-19 data until July 2020, an estimate of the transition intensity using the maximum likelihood approach was obtained, where for estimate of the intensity of the transition were obtained, namely susceptible to infected, susceptible to death, infected to recover, infected to death, and recover and susceptible. The result of the transition intensity estimation are used to construct the R0 value with the next generation matrix method. Because the R0 obtained for the COVID-19 spread model is still more than 1, it shows that the spread of COVID-19 in Indonesia has not ended. Okay, thank you for the time given to me. Please correct me if there are errors in the delivery of this presentation. I end my presentation with Assalamualaikum warahmatullahi wabarakatuh.
Thank you for video presentation from Ibu Faizatus Suhaira. So we continue with discussion. Maybe there are questions from other presenters.
I have a question.
Yeah, Bu Helisha, please.
Yeah, thank you so much. For Ibu Faihatus, I would like to ask you about, in your method, you need initial value of parameter. As in your slide, you have parameter R, I, and D in the compartment diagram. So I'm wondering how the parameter is used or not to calculate the R naught or basic number.
Please repeat again.
Yeah, I'm wondering the parameter R, I, and D in the SRD model is used to calculate the R naught or not. Hello.
Hello, ya.
Maybe you can
Indonesia aja.
Iya, no problem.
Iya, gini Bu, apa namanya di diagram kompartemen tadi kan ada beberapa parameter, ada parameter R kecil, terus D sama I kalau nggak salah. Ya, nah saya di sini mau tanya, untuk itu apakah digunakan parameter tersebut digunakan tidak Bu untuk menghitung R0 di metodenya Ibu?
Iya, terima kasih atas pertanyaannya. Saya jawab bahasa Indonesia aja juga ya. Jadi untuk yang gambar 1 itu saya hanya menunjukkan
untuk model kompartemen itu menggunakan parameter-parameter S kecil, I kecil, R kecil, dan D. Nah, untuk di model saya karena menggunakan intensitas transisi itu menggunakan gambar yang berikutnya. Jadi tidak digunakan parameter seperti di model kompartemennya, Bu. Jadi saya menggunakan yang seperti gambar berikutnya yang mu12, mu23. Jadi intensitas transisi di sini nanti saya dapatkan dari berapa banyaknya yang bertransisi dibagi dengan waktu dia menetap di state tertentu gitu, Bu.
Oh, okay. Cara cara mengetahui dia bertransisi dengan, maksudnya transmisinya itu tadi gimana, Bu? Pakai data apa kira-kira?
Ya, jadi saya mengambil data dari web BNPB. Nah, itu saja. Jadi yang saya pakai di sini adalah yang positif, yang positif COVID, kemudian yang sembuh dengan yang meninggal. Nah, di sini untuk transisi misal mu12 itu kan intensitas transisi dari suspek ke terinfeksi. Jadi berapa banyaknya orang-orang yang terinfeksi di situ. Kemudian kalau misalkan infeksi ke sembuh berarti berapa banyaknya yang sembuh untuk mu23.
Okay. Yeah. Thank you the discussion. Maybe there are question again from Helisha.
Yeah, thank you so much. Terima kasih, Bu.
Okay, thank you, Helisha, and maybe Bu Faihatus can close your presentation. Maybe you can close your presentation, Bu.
Okay, thank you so much for the opportunity given to me.
Okay, for the next presenters, the paper by title Efficiency Parameters Estimation of Spatial Turbine Model on Advertisement Tax Revenue in Malang City by Ibu Nur Atika, Profesor Basuki Widodo, Swasono Raharjo, Mardia, Nur Khalifa, and Afifa. Please, time is yours.
Okay, thank you, Mr. Hakam. Introducing, I am Nur Atika. I am a doctoral student in the Mathematics Department, ITS Surabaya. Alhamdulillah, here are two of my supervisors, Professor Basuki Widodo and Dr. Mardia. Next, I will show a video presentation of my paper.
I'm sorry, Bu Atika, would you please share your computer sound?
Okay.
In sharing option, Bu, if you wanna share your computer sound.
Sudah apa belum? Belum.
Maybe you can play again your video presentation.
Okay.
I think still can hear clearly. We still can hear clearly, or maybe we can play for you.
Yes, thank you.
Okay.
wabarakatuh. Good afternoon, ladies and gentlemen. Thank you to the Icompac Organizing Committee for the year 2020 for the opportunity given to me and the team to present our paper. I am Nur Atika with the team Professor Basuki Widodo, Dr. Swasono Raharjo, Dr. Martia, Diah Lailizatul Afifah, and Nadia Kholifia. We will present a paper entitled The Efficiency of Spatial Darwin Model Parameters Estimation on Advertisement Tax Revenue in Malang City. Spatial regression is the development of simple linear regression, in which there exists a spatial effect on the data to be analyzed. The spatial effects that arise on the spatial regression are spatial heterogeneity and spatial dependence. The spatial heterogeneity shows the differences in characteristics from one region to another, while the spatial dependence shows the dependence between adjacent areas. In general, there are several types of spatial models, namely spatial autoregressive model, spatial error model, spatial Darwin model, and spatial autoregressive moving average. Spatial Darwin model is a spatial regression model developed from the spatial autoregressive model. Spatial autoregressive model only considers the effect of the spatial lag on the independent variables. Meanwhile, the spatial Darwin model considers the effect of the spatial lag on the independent variables and the dependent variable. The estimation methods that can be used are maximum likelihood estimation, Bayesian generalized method of moment, and method of moment. Since the year 2000, the government has started to implement regional autonomy. With the regional autonomy policy, local governments have a significant role and are required to be creative in exploring the potential of their regions to maximize regional original income and regional taxes. The definition of tax is the contribution that must be paid by individuals or entities to the state, which is compelling based on law. Tax is one component that has the potential to contribute to increasing regional original income. Malang City is one of the big cities in East Java, which is experiencing development with more and more immigrants studying and working. It causes an increasing number of business and industries in Malang. By the increasing number of business and industries, the increasing need for advertisement services can increase billboard tax revenue. The advertisement tax is one of the potential sources of regional income and plays an essential role in increasing the regional original income of Malang. To optimize advertisement tax revenue, Malang City government needs to know the factors that have a significant influence and map the areas that can increase the advertisement tax price. The amount of tax revenue in one area will affect other regions. Likewise, with advertisement tax revenue, so it can be said that advertisement tax revenue has a spatial effect. In this paper, we will discuss the efficiency of the spatial Darwin model parameter estimation by using maximum likelihood estimation and method of moment in which the population data take account many billboards, advertisement installation period, types of advertisements, number of industries, and gross regional domestic product as independent variables that affect billboard tax revenue. In the spatial Darwin model, the dependent variable and the independent variables have spatial interaction. Spatial Darwin model in general can be written in the form of a matrix like the following in the slide. The following is an estimate of the spatial Darwin model parameters using the maximum likelihood. Parameter beta are estimated by maximizing the log likelihood function by deriving the equation for beta, obtaining stationarity conditions. And parameter sigma square are estimated by maximizing the log likelihood function by deriving the equation for sigma square. The following is an estimate of the spatial Darwin model parameters using the maximum likelihood. And this one is the spatial Darwin model parameter estimation using the moment method, the following in the slide. In this study, using secondary data obtained from the Malang City Regional Tax Service Agency in 2018, the data used are advertisement tax data as a Y variable, population X1 variable, many billboards X2 variable, installation period of billboard X3 variable, type of billboard X4 variable, number of industries X5 variable, and gross regional domestic product X6 variable. And statistical software used in this study is R4.0.2 software. Then the data analysis steps. The first step, multicollinearity testing using variance inflation factor. Second step, spatial Darwin model parameter estimation using maximum likelihood estimation and method of moment. Next, testing the model residuals of maximum likelihood estimation and method of moment. There are 3 tests for the residual moment, namely normality test, spatial heterogeneity test, and spatial autocorrelation test. Fourth step, determine the best estimate for a spatial Darwin model using mean square error. And the last step, data mapping and data interpretation. The first step is to detect multicollinearity for each independent variable. Based on the results in table, it's known that the VIF value of all independent variables is less than 10. So, it can be concluded that there is no multicollinearity. The first step is to detect multicollinearity for each independent variable. Based on the results in table, it's known that the VIF value of all independent variables is less than 10, so it can be concluded that there is no multicollinearity. Then detects whether the data meet the assumption of spatial autocorrelation. Based on the table, it can be seen that the p-value of Moran's I on the remaining is less than the real level of 5%, so HO is rejected. Then detects whether the data meet the assumption of spatial autocorrelation. Based on the table, it can be seen that the p-value of Moran's I on the remaining is less than the real level of 5%, so HO is rejected. Next, estimation of spatial Darwin model parameters using maximum likelihood, and the results are in the table. So that the equation is as follows in the slide. The next step, test the rest. From the 3 tests, all the assumptions are appropriate, namely the error is not autocorrelated, spatial homogeneity, and is normally distributed. Estimation of spatial Darwin model parameters using method of moment, and the results are in the table. So that the equation is as follows in the slide. Next step, test the rest. From the 3 tests, all the assumptions are appropriate, namely the error is not autocorrelated, spatial homogeneity, and is normally distributed. Next, testing the goodness of the parameter estimation method and can be seen that the maximum likelihood estimation method has a smaller mean square error value than the moment method mean square error value. It shows that the maximum likelihood estimation method is more suitable for modeling advertisement text data in Malang. The final step is mapping the advertisement tax revenue based on the spatial Darwin model equation using the maximum likelihood estimation. Based on the results of the analysis with the spatial Darwin model approach, it's obtained that the advertisement tax revenue value is divided into 5 classes. Based on Figure 1, it can be seen that two urban villages fall into the very high category, namely Gadang and Bandulan village, respectively. The Gadang village is in the very high category because there are terminals and lots of shops. Meanwhile, the Bandulan village is a village located on the border between the regency and the city. Besides, there are several factories. Therefore, the installation of billboards in the two villages has an excellent opportunity to be read. Conclusion is based on the mean square error value. Spatial Darwin model parameter estimation using maximum likelihood estimation is better than the moment method for analyzing advertisement tax revenue in Malang City in 2018. Based on the advertisement tax revenue obtained from the spatial Darwin model with the maximum likelihood estimation approach, obtained as many as 2 urban villages are in the very high category, 9 villages are classified as high category, 18 villages are in the medium category, 19 villages are in the low category, and 9 villages in the very low category. Conclusion is based on the mean square error value. Spatial Darwin model parameter estimation using maximum likelihood estimation is better than the moment estimation is as high. The presentation of our research. I'm sorry if there are flaws and mistakes. Wassalamualaikum warahmatullahi wabarakatuh. The presentation of our research results. I'm sorry if there are flaws.
Okay. I think have a problem with video. There are
Sorry.
repeat uh, some uh, conclusion. Okay, maybe
Yeah.
there are question for Bu Nur Atika. If there isn't there are not question, maybe we can go to next presenters because we have limited time. Maybe how about that? We can continue the next presenter.
Yes. Thank
Okay.
you.
Thank you, Ibu Nur
Thank
Atika,
you,
for your
Mas
video
Hakam.
presentation. Then for the next presentation from the paper by title Determining the Optimal Window Line of the Time Varying Copiola Parameter, a simulation study by Atina Ahdika, Dedi Rosadi, Atia Roni Effendi, and Gunardi. Please, time is yours.
Okay, thank you very much for the time. I will try to share my video.
Yeah.
Okay.
Thank you very much for the time given to me. I am Atin Andika from Department of Mathematics, Universitas Gadjah Mada. Thank you very much for the time given to me. I am Atin
Okay, is
Andika from
the
Department of
sound clearly
Mathematics,
heard?
Universitas Gadjah Mada. Today I would like to present a part of our research in copula modeling entitled Determining the Optimal Window Length of the Time-Varying Copula Parameter Through a Simulation Study. Generally, in this research, we conduct a simulation study to determine the best length of the last observation that has a significant effect. Sorry, the moderator, can you hear the video sound?
Yes.
In determining the
Yes,
strength
it's
of
clear.
dependence between marginal variables in time-varying copula modeling. Here are the outline of our presentation today. First, we will convey briefly about the background of this research. Then we will present a brief overview about the time-varying copula, and then we provide the result of the numerical simulation in determining the optimal window length of the time-varying copula parameter. We also provide the application of our research to the empirical data, and the last, we will conclude the results of our study. First, starting with the study of the dependence modeling, there are two popular approaches in the dependence modeling field. The first is linear modeling, which we are familiar with, such as the correlation coefficient or regression modeling. And the second is a study that is quite popular and continues to be developed, known as copula modeling. There are some pitfalls in the linear modeling, especially in the correlation coefficient. First, correlation is simply a scalar measure of dependency. It cannot tell us everything we would like to know about the dependent structure of the marginal variables. And then, possible value of correlation depend on the marginal distribution. It has to form a bivariate normal distribution. Then zero correlation does not always mean independence, and thus, correlation is not invariant under transformation such as log function. There are alternatives to overcome these limitations, such as using rank correlation or tail dependence, which can be expressed in copula function. Along with the development of research in the field of copula, the copula parameter, which is generally static, has been developed to become a parameter that is dynamic in nature. This dynamic parameter describes the dependence which changes over time and is considered suitable to describe the dependence structure, especially in the fields of finance, insurance, or climatology. These methods known as time-varying copula. Some researchers proposed the evolution equation of the dynamic parameter of time-varying copula as a function of the autoregressive process. Patent in 2006, Hafner Manner, Hans Manner, and Reznikova in 2012 proposed the function of the autoregressive moving average with order of 1 and 10 as the evolution equation of the dynamic parameter of time-varying copula. Then in 2010, Diaz and Embrecht proposed an autoregressive moving average with order 1 and 1 as the functional form of the dynamic parameter. The recent studies in 2018, Su et al. And in 2019, Manner et al. Proposed a generalized autoregressive score with order of 1 and 1 and a latent Gaussian autoregressive 1. In general, the dynamic parameter of time-varying copula can be considered to follow an autoregressive moving average process, where the process consists of an autoregressive part, which explains the effect of the previous parameter, and a forcing variable in the moving average part, which describes the effect of the length of the past observation to the structure of dependence between the marginal variables. However, there is no specific judgment on how to determine the length of the past observation in the calculation of the dynamic parameter. Therefore, we aim to determine the optimal window length of the dynamic parameter of time-varying copula by considering the window length of the past observations as a new parameter that must be estimated. Okay, this is the definition of the time-varying copula. In general, Copula is a multivariate distribution function that couple the distribution function of the marginal variables with the dynamic parameter. In this research, we use 4 types of copula which explain the copula having zero tail dependence, that is normal copula, having lower tail dependence, that is Clayton copula, having upper tail dependence, that is Campbell copula, and having both lower and upper tail dependence, that is symmetry Joe-Clayton copula. This is the copula specification of the 4 types of copula we used in this research. To obtain the optimal window length, we define the 4 parameters to be estimated that are omega, beta, alpha, and m, such as in the following equations. To obtain the optimal window length of the temporal parameter of time-varying copula, we conduct a numerical simulation. We generate a joint vector of residual, each follows a gamma distribution. This type of distribution shows that copula can handle the structure of dependence of non-elliptical distribution. Table 2 shows the characteristic of the data generation for each copula. We conduct 3 simulations, consist of simulation with strong positive dependence, weak dependence, and strong negative dependence. However, the strong negative dependence simulation is conducted only for normal copula because the range of parameters for the other 3 copulas are in the positive value of dependence. Here are the simulation results. Figure 1, figure 2, and 3 show the estimation result of the strong positive dependency, weak dependency, and strong negative dependency. The 3 figures show that the last one observation greatly influenced the temporal parameter and has a small likelihood of being affected by a long period of observations in the last. This result is evidenced by the decreasing percentage of the window length appearance for the longer period from previous observations. Therefore, we can conclude that we cannot determine the window length by picking any positive integer values. Otherwise, the window length has to be treated as a parameter that must be estimated. Moreover, we cannot guarantee specific number that will produce the optimal parameter estimates. However, we can ensure that the smaller the amount of window length m, the more significant the effect of m past observation to the value of the dynamic parameter. In our empirical application, we will investigate the dynamic dependency between the price index received and paid by farmers, informing the farmer exchange rate as one of the indicators of farmers' welfare. This is the original and the transformed data of the variable. It is being transformed because it has different base year. This is the result of the marginal modeling using ARIMA model. And this is the parameter estimates of the time varying copula. This figure shows the temporal upper and lower tail dependence that we obtain from the best copulas like this selected that are the time varying symmetry Joe-Clayton copula with the window length of 5. It shows that the 2 variables have both upper and lower dependence. This is the model prediction and the performance measurement. The values of the mean square error and mean absolute percentage error are quite small. Therefore, we can say that the time varying symmetry Joe-Clayton copula with the optimal window length of 5 gives a good estimation result. The last part is a simulation to improve the accuracy measure of the prediction. We change the mean and standard deviation of the residual pairs without changing the dynamic dependence measure. We can see that the smaller the mean and standard deviation of the residual pairs, the more accurately the model in predicting the farmer exchange rate. So we jump to the following conclusion. First, numerical simulations show that the optimal parameter, specifically the window length, does not always come from a specific number. So we have to treat the window length as a new parameter. Then The optimal window length that often appears from 1000 iteration in each type of coupler is sort order from the last observation. Therefore, the longer the period of the previous observation, the smaller the impact on the dynamic parameter. Then, the accuracy of the predicted data can be obtained by minimizing the mean and standard deviation of the residual pairs, which are generated from the selected time-varying popular models. I think it's enough from us. Thank you very much.
Thank you, Bu Atina Ahdika, from your video presentation. So we continue with discussion. Maybe there are questions from the other presenters. I mean. If we don't have any question, maybe we can continue the next presenter. Okay, thank you, Bu Atina Ahdika.
Yeah, you're welcome, Pak Hakam.
Okay, so the next presenter, the paper by title Stability Analysis of a Fractional Order Leslie Gower Model with Ali Effect in Predator by Emily Rahmi, Isnani Terti Agus Suryanto, and Trisilowati. Time is yours.
Thank you. Can you hear my voice?
Yeah.
Okay. Okay, I want to share my slide. Can you see my slide?
Yes, ma'am.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and thank you. My name is Emily Rahmi. I'm a student in Department of Mathematics, University of Brawijaya. Now I want to share the result of our research about the stability analysis of a fractional order Leslie-Gower model with Ali effect in Predator. First of all, let's consider our first order system for modified Leslie-Gower model with Ali effect in Predator as in equation 1. This model was adopted by the previous model proposed by Feng and Kang, but now with different functional response and assume that the Ali effect only exists in predator population. N and P are the density of prey and predator. This term denotes the Ali effect function, and this term denotes the Beddington-De Angelis functional response. Okay, in many situations, the growth rates of prey and predator depend not only on the current state, but also on the history of variable or its memory effect. So in this research, we replace the left-hand side of model in equation 1 with Caputo fractional order derivative as in equation 2. Next, in order to simplify our model in equation 2, we introduce the following non-dimensional model as in equation 3. To explore the dynamical behavior, we used theorem 1, the Matignon condition. From this theorem, we can see that the stability region of fractional order system depends on the absolute value of the argument of eigenvalue. There is the angle between the real part, the positive real part of the eigenvalue and the imaginary part of eigenvalue. Based on theorem 1, in our model, We have 4 type of equilibrium points. It is both prey and predator extinction, which is always exists. The prey extinction point, which is exists if satisfies this condition. The predator extinction point, which is always exists, and the interior point, the existency is stated in theorem 2. The proof is given here. Okay, next to analyze the stability of the equilibrium point, we applying the linearization to the model, finding the Jacobian matrix, evaluating the eigenvalue, determining the argument of the eigenvalue, and utilizing the Matignon condition. By that, we obtain the local stability of E0, E1, E2, and E star. E0 is always unstable. The proof is given here. E1 is locally asymptotically stable if satisfies this condition. E2 is non-hyperbolic points since the eigenvalue is equal to 0, so we need a further analysis to determine the stability. And the last is E star. E stars is locally asymptotically stable if satisfies one of these 2 conditions. The proof is given here. Okay, the interesting phenomena which occurs in our model is the existence of Hopf bifurcation. So before we show the existence of Hopf bifurcation in our model, we first give the difference of the occurrence of Hopf bifurcation in first order and fractional order. Let's see this stability region. Basically, Hopf bifurcation in both operators are indicated by a pair of complex conjugate eigenvalues. We can see in this complex plane of eigenvalue for the first order, Hopf bifurcation occurs when the real parts of eigenvalue change its value from negative to positive or from positive to negative by changing the parameter bifurcation. For the fractional order model, the stability region depends on the order of the derivative. So instead of varying the biological parameter, we interested to study the occurrence of Hopf bifurcation driven by the order of the derivative. In this region, the equilibrium point is stable if alpha pi per 2 is less than the argument of eigenvalue. But when the alpha cross the critical value alpha stars, the equilibrium point will change to unstable. Here in theorem 7, we prove that the interior point in our model occurs Hopf bifurcation. To demonstrate the dynamics of our model, we give the following numerical simulation by applying the predictor corrector for fractional order. The first is the best portrait of model in equation in equation 3. From this picture, we show the 2 unstable point E0 and E2 and 1 stable point E1. From this numerical simulation, we know that the A2 is a saddle point. Okay, next, by increases the parameter, wait a minute. By increases the parameter theta to 0.4, and equilibrium point E star, it is emerge in interior. If we set alpha equal to 0.7, E star becomes locally asymptotically stable as in figure 2a. But when we set the alpha equal to 0.74, E stars lose its stability as in figure 2b. This phenomena is called Hopf bifurcation as mentioned in theorem 7. Next, in this picture, we exhibit the influence of the order of the derivative. In this picture, we find the value of alpha. We indicate numerically that the greater the order of the derivative, the faster the solution converges towards to the equilibrium point. Next, we also give the impact of the Allais effect constant to the solution of the model. We show that when the Allais effect constant theta increases, the density of prey increases and the density of predator decreases. Okay, here is the reference. I'm sorry, the conclusion, I think it's gone. Okay, I think here's the reference, and thank you.
Thank you, Bu Emily Rahmi. So we continue with discussion. There is a question. There are questions from any presenter.
Yeah, Mr. Akam, can I ask a question?
Yeah, please, Mr. Abadi.
Okay, thank you. Bu Eli, could you explain about the meaning of the LA effect in your model, and also when you consider the fractional dimension, yeah, for the parameter value, then, and if you compare with the first order, is there any different meaning biologically for that condition? Thank you.
Okay, thank you, Mr. Abadi. The Allais effect in this research is referred to a condition where at lower population density, the per capita growth rate of population, the per capita growth rate and population density is correlate positively. So it is the meaning of the Allais effect. So like that. And why we choose the fractional order than the first order is because in fractional order there is the solution of fractional order is depend on the whole time of the variable. I think yes, it's depend on the history of the variable. It's depend jadi on the fractional order. The solution it's depend on the history of the variable, which in the first order the solution just depend on the current state, not on the history of the current, not on the history of the variable.
What
Like
is different in the meaning then?
So it's some research have proved that have showed that with using fractional order, it can the model can give the close apa, the can give the close the solution is near to the real condition. The solution is the solution is near to the real condition, like that.
Yes, thank you.
But in our research, of course, because we don't have any real data for this model, so we couldn't prove that our model is near to the real condition, like that. I'm sorry, my English is not good.
Very good.
Any question with from Mr. Abadi?
I think it's enough. Thank you.
Okay. Thank you, Mr. Abadi, and thank you, Bu Emily Rahmi.
Yes, thank you.
Yeah,
You're welcome.
Maybe you can close your presentation before we go to the next presenter.
Okay, thank you.
Okay. We continue the presenter paper by title Decentralized Extended Kalman Filter of Multi-Robot Position by Erna Apriliani, Martia, Didik Husnul Arif, Helisha Nurfadila. So, time is yours. Maybe I play your video presentation, Bu Helisha.
Yes, please. Thank you, Pak Hakam.
Introduce myself. My name is Helisha Fadila. I'm from ITS. Now I will present our paper with the title Decentralized Extended Kalman Filter of Multi-Robot Position. And here we have the overview. So today I will present about introduction, decentralized extended Kalman filter, simulation results, and the conclusion. And first we have the introduction. In recent years, significant developments have taken place in the field of robotics, where researchers have begun to develop their research from the investigation of the single robot system to a multi-robot system. Localization is one of the most important issues in the study of a multi-robot system. Not only the localization, but also multi-robot system communication is an important part of the multi-robot system. However, for certain reasons, such as environment, sometimes communication between robots cannot be done as a whole, or in other words, not all robots receive information from other robots. A new approach is needed that can be present in a multi-robot system called decentralized estimation. Since the multi-robot system is non-linear, we use modification of the Kalman filter, extended Kalman filter, and for decentralized scheme, we call decentralized extended Kalman filter. In the decentralized estimation scheme, it's not is making its prediction. We assume that some nodes will transfer the information of measurement with their closed neighbors. After that, we can find the position of estimation of each robot. And in this case, in this paper, we use 5 robots in the system to demonstrate the decentralized extended Kalman filter. Next, we have the multi-robot system. So a nonlinear multi-robot system defined by u.I, v.I, and omega.I. As I said before, here we use 5 robots, so I equal 1, 2, 3, 4, and 5. And for the computation, we use the discrete model for nonlinear model, so we get the ui k plus 1, vi k plus 1, and omega I k plus 1. And here eta u, eta v, and eta omega are the system noise assumed to be Gaussian white noise. An extended Kalman filter has two main states to estimate. They are predict and update. So in the predict step, we can predict the state ahead and predict the error covariance ahead. In the update step, we can compute the Kalman gain and update the estimate with measurement data and update the error covariance. And the process of predicting and updating runs recursively until certain steps in time. And in the mathematics formula, we get this equation for predict and update steps. We can call this algorithm with centralized extended Kalman filter. And next, in the decentralized extended Kalman filter, each node is making its prediction or collect their measurement. For simplicity, we assume that each node can use the information from its subsystem. And note that the centralized Kalman filter update step is mathematically equivalent to the centralized extended Kalman filter update step. And with identical initialization, the decentralized Kalman filter provides exactly the same state estimates as the centralized Kalman filter. And next, we go to simulation result. Now we have the multi-robot system with the full communication. So with the centralized extended Kalman filter, we can estimate the position of each robot. So in this figure, we use the time step equal 100, and for the next simulation of the decentralized extended Kalman filter, we use the same initial value and the same time step with the centralized extended Kalman filter. Let's move on to the decentralized extended Kalman filter. Here we have the multi-robot with limited communication. So here you can see that R1 has information of measurement from its own and R2, and R2 has information of measurement from its one, R1 and R5, and R3 has information of measurement from each own and R1, and R5 has information of measurement from each one only, and the last R5 has information of measurement from each one and R2. And in the decentralized extended Kalman filter, here occur in the time step k more than 13 and less than 80. So for the other time step, in this case, for the time step 0 until 30 and 81 until 100, we use the centralized extended Kalman filter. So here the estimation of R1 position, and here the estimation of R2 position. So you can see that here this is the decentralized extended Kalman filter with the same time step with the previous or with the R1 position. And here you can see the difference between the decentralized and centralized extended Kalman filter for estimation of R3 position. And here for R4 position. And the last one is the R5 position. So you can see that the centralized estimation for R1 position, R5 position I mean. And to know the accuracy of the decentralized extended Kalman filter, we calculate the relative mean absolute presentation error between the estimate, both of the centralized and decentralized, and the actual data. So here you can see that the error quite small, but you know the decentralized can achieve the better performance as centralized, because you know the information in the decentralized extended Kalman filter not as complete in the centralized extended Kalman filter. But now we can see in the error difference between centralized and decentralized that the decentralized extended Kalman filter gives a pretty good performance compared with the centralized extended Kalman filter. And next we have the conclusion of our research. So the decentralized extended Kalman filter is a modification of the Kalman filter that can be used to solve multi-robot position estimation problems with limited measurement data. Based on the simulation result, the decentralized estimation in particular has a larger error than the centralized ones. The results are reasonable because in the decentralized scheme, we cannot collect the measurement data as complete as the centralized scheme. The results are pretty good because the error difference between the centralized and centralized extended Kalman filter in position estimation of multi-robot is quite small. And thank you.
Okay, thank you for the video presentation from Bu Alicia. So we go to discussion. There are questions from other presenter maybe. Okay, maybe from me, Bu Halisha. I interest in your simulation. Why R5 always maybe they have the error, the biggest error if we compare with R1 to R4.
Yeah, thank you, Pak Hagam, for the question. So in the simulation, we use different initial value of each robot. So for robot 1, robot 2, until robot 5, we use a different position of U position, of V position, and omega position. So uh, actually, I'm not sure about the reason why the R5 always have the biggest error, as you said, but maybe the choice of initial value is have impact to the simulation results, something like that.
Okay, okay, I think enough. Maybe there are question again from the other. Okay, if we don't have any question again, maybe Bu Halisha can close your presentation.
Yeah, thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, we continue the next presenter, the paper with the title Monte Carlo method to evaluate GAT bond of fluid in Surabaya under jam diffusion process by Hengki Kurniawan, Endah Putri, Khairul Imran, and Dedi Prastio. Please, time is yours.
Okay, thank you, Mr. Hakam. Oh, thanks. Today we'll present our research paper about Monte Carlo method to evaluate cat bonds of flood in Surabaya under jam diffusion process. So in this research, the price of flood cat bonds is calculated based on run of discharge and flood loss that is modeled by jam diffusion process. Coefficient is determined based on hydrological discharge and hydraulic discharge. This
Sorry,
research
Hengki.
is written by me, Hengki
Yeah.
Kurniawan, Mrs.
Mr. Hengki.
Enda Almati Merdeka Putri, Professor Khairul Imran, and also Mr. Dedi Dwi Prastio.
Your video cannot, we can see your
Presentation
video, Hengki.
today will be started by introduction, followed by hydrological discharge,
Maybe you can
hydraulic
reload again
discharge,
your video.
flood and losses, cat bonds, and will be ended by conclusion. As the first introduction.
Okay.
How is it?
Yeah.
According to the Badan Nasional Penanggulangan Bencana or BNPB, there have been 1,426 natural disasters in 2019. The number of disasters tends to increase from year to year so that it gives an impact in the form of increased disaster risk. In 2019, floods ranked second as a disaster with the highest frequency of occurrence. Tornado was the most frequent disaster with 568 recorded events, followed by floods with 385 recorded events. Following BNPB notes, the total loss caused by the flood in 2019 entirely has reached billions of rupiah. Much research has been done on the cat bonds. One of them, bought off in 2019, modeled cat bonds valuation as a linear function of losses incurred to analyze the market price of cat bonds. Funson in 2013 shows that the cat bonds, in addition to being affected by disaster risk, are also influenced by exchange rate volatility and its correlation with the interest rate. Siama in 2019 conducted a comparative analysis of the valuation of cat bonds influenced by currency exchange rates using the Monte Carlo method and the quasi-Monte Carlo method. The goals of this study are to get flood loss index, cat bond valuation model, and price analysis by Monte Carlo approach. Next, hydrological discharge. Hydrological discharge is influenced by maximum rainfall and watershed specification. The maximum rainfall is predicted using the regression method based on data of maximum rainfall from 6 urban villages in Surabaya. These 6 urban villages are Keputi, Gunung Cowe, Gubeng, Wonorejo, Gunung Kromo, and Gunung Sari. The watershed specification for each watershed is obtained by randomizing the specification type. So here is maximum rainfall prediction using linear regression. And maximum rainfall prediction using Gaussian process regression. This Gaussian process regression curve can be said very coincide with the real curve, with only 0.96865% of MAPE value. There are several formula that needed in this paper. The first one is combined drainage coefficient, which is a weighted average of the drainage coefficient. Next is Kirby formula to calculate the concentration time. And then the third formula is Mononobe formula to calculate the maximum intensity of rainfall in 24 hours. And then the last is rational method to calculate the hydrological discharge using rational method. Next is hydraulic discharge. To calculate hydraulic discharge, we need to calculate the hydraulic radius for each channel, and then the calculated hydraulic radius then used to obtain the flow rate based on the running formula to get the hydraulic discharge. Next, flood and losses. Factors considered to determine the losses caused by floods are regional factors, life factors, and multipliers. From its area expected to be exposed by floods, the area of the flooded area is the area multiplied by a random number. From its area exposed to flooding, the number of individuals exposed to flooding is the number of lives in the area multiplied by a random number. The multiplier factor is a comparison of the hydrological discharge with the hydraulic discharge. Using the loss equation before, we can get the loss for each urban village, and the losses from the 6 urban villages are added up to get the sum loss. And from this sum loss, we can get the cumulative version of losses. And we use the value loss per person 25,000 and loss per area 10,000. Loss prediction is done using the jump diffusion process curve that best matches the existing loss curve. As this is a random curve, it means can be moved up or moved down. And as the cumulative loss curve is a rising monotonous curve, an adjustment procedure is needed for the resulting curve. So the adjustment made is if the loss at t is smaller than the loss at t minus 1, then the loss at t is equal to the loss at t minus 1. And then when we edit the jump part, it will be jump diffusion process, or the famous one is Merton's jump diffusion process. Next, cat bonds. The cat bond price model can be obtained by looking for expectation of the form cash flow C multiplied by discount factor D. In the cash flow, there is a trigger time for the cat bond, which will be denoted by eta. The eta value is the first time the loss value reaches the threshold h, or in the other words, eta is the minimum t where the cumulative loss at time t, or lt, is greater or equal to h. After getting the required model, the Monte Carlo simulation is constructed to obtain cash flow expectations. Then it's needed to analyze the relationship between cat bond prices and the input parameter. As the first analysis, the relationship between cat bond prices and number of iterations are tested. In the simulation, the value of the number iteration is start from 1100 to 10,000 with a step of 100. In the simulation, the value of threshold is set at 6 times 10 to the power of 8. The value of proportion reduction is 0.8 and the interest rate is 0.05. Then we look for the effect of the threshold on the price of cat bond. In this simulation, the value of threshold starts from 1 times 10 to the power of 8 to 50 times 10 to the power of 8 with the step for 10 to the power of 8. In this simulation, the number of iterations is set at the value of 1000. The value of proportion reduction is set at the value of 0.8 and the interest rate is 0.05. Then we look for the effect of the value of proportion reduction on the price of cat bond. In this simulation, the value of proportion reduction starts from 0.01 up to 0.9 with step of 0.01. In this simulation, the number of iteration is set at the value of 1000. The threshold is 6 times 10 to the power of 8 and the interest rate is 0.05. As the last simulation, we look for the effect of interest rate to the price of cat bond. We start interest rate from 0.01 up to 0.2 with step for 0.01. In this simulation, the number of iteration is 1000, the threshold is 6 times 10 to the power of 8, and we got this figure. Finally, conclusion. As the conclusion, the model used to calculate the losses per area is the number of individuals who are victims multiplied by the amount of loss per person plus the area of submerged area multiplied by the amount of loss per square meter. The result of the sum then multiplied by the multiplier factor. The calculated losses then will be modeled. Based on this loss model, cat bond price for a flood is determined by the expectation of the product of the discount factor multiplied with the cash flow. Next, number of iterations doesn't significantly affect the price of cat bond. Threshold greatly influence the price of cat bond, especially at value between 1 times 10 to the power of 8 to 20 times 10 to the power of 8, whereas for threshold more than 2 times 10 to the power of 8, the price of cat bond remains increased, though not significantly. Proportion of reduction that is getting bigger result in a price reduction on the cat bond. Interest rate is enough to affect the price of cat bond, where for an increasing rate will cause the price of cat bond continues to decrease. It's been an honor to be among such accomplished individuals and to be able to present our perspective before you all. Thank you.
Okay, thank you, Mr. Henky. So we go to discussion. There are questions from other presenter. Maybe from me, Mr. Henky, you say that in conclusion, number of iteration does not impact gitu ya. So how minimum number of iteration that you need to get the result?
Okay. Thank you for the question. So, because of this is a stochastic simulation, so there is no minimum number of iteration, but the more iteration that we did, the simulation will get convert earlier rather than using a small amount of iteration. So maybe that.
Okay, thank you, Mr. Hengi. Maybe other question? If we don't have a question again, maybe you can close your presentation, Mr. Hengi.
Okay, that's all for my presentation today. And once again, thank you.
Thank you, Mr. Henki. And we go to the next presenter. That is about spreading dynamic of infectious disease into interacting areas by Kamiran, Basuki Widodo, Haryanto, Nur Asia, and Amirul Hakam. Yes, this is my study. So I will share my video presentation. Let me introduce myself. My name is Amirul Hakam. I will present my paper with the title Spreading Dynamic on Infectious Disease into Interacting Areas with Mr. Kamiran, Basuki Widodo, Haryanto, Nur Asia from Mathematics Department Institut Teknologi 10 November Surabaya. I will present in this presentation from introduction, then developing a mathematical model, solution and simulation of mathematical model, and summary. The first introduction. The spread of infectious disease phenomenon can be approached using a mathematical model. With this mathematical model, it will make it easier to analyze real problem. From the solution to this problem, we can simulate the problem. The model of disease spread, that is model will be a paired nonlinear differential equation system as a representation of two groups. The model for the spread of infectious disease is analyzed from the interaction between susceptible S and infected E and recover R and dead D and other population. Susceptible, its mean population in group that is susceptible to disease, and then exposed or E, population in group that is infected with the disease and can transmit the disease but has not shown any initial symptoms. An infected population, population in group experience symptom. In this study, we will investigate the case of the spread of infectious disease that occur in two groups. The concept of the network for the spread of infectious disease into group is necessary because there are differences in the level of transmission between the two groups. The spread of infectious disease is shown as follows this compartment diagram. Index 1 and 2 show that there are two groups, the first group and the second group. Susceptible or S is at high risk of being infected from infectious disease. S population might be contact with E population from the first group and the second group and decrease because there is a natural death. An exposed population will increase because they are contact with susceptible population, but decrease because infected or natural death. An infected population will increase because new population come from exposed population. Based on the compartment diagram, we can develop a mathematical model for rate of change S, E, and I population. This will be a system differential equation. And there are some parameter GI from S population. It means natural death rate of S population, and DI from exposed population, its natural death rate from exposed population, and DI natural death from infected population. And there are parameter that is recruitment rate of population in group. And then there are beta, it means chance of cross transmission between group I and G, and the current infected individual in group symbol by theta. And there are epsilon, incubation rate in group E. Basic reproduction number can be obtained from eigenvalue of M0 matrix, with M0 is initial of S1 and S2 from the first group and second group. So we can formulate like this. Basic reproduction number or notation by R0 can be obtained from this matrix M0. And we solve this equation and we get the formulation of basic reproduction number. And we have two cases in this study. The first case is the first group is free disease and the second group is endemic. So beta from first group and second group is 0. So we have the basic reproduction from this case is like this, R1. It means basic reproduction number for case 1. And the second case, the first group is endemic, and the second group is free disease. So beta index 1, 2 equal to beta index 2, 2 and equal to beta 2, 1 equal to epsilon 2 equal to theta 2 equal to 0, and we have basic reproduction number for second case following this equation. And we choose this parameter to simulate the differential equation. The parameter we get by trial and error, and we just to know what the effect of this parameter in this simulation. So the first simulation, we applied this to the first case. That is, the first group is free and the second group is endemic. So we can know about this feature. The population from the first group S1 is decreased because there is exposed increase and infected population increase. Same with the second group. The second group S2 is decreased because there are A population and I population is increased. And the second simulation is using this parameter. For this case, first group is endemic and second group is free disease. And we can look at this feature. S1 population is increased, yeah, and then S2 is decreased because there are effect from the first group. And the conclusion, the rate of change in the exposed population increase equal in both of group. This is due to the presence of a large enough disease transmission rate so that many individuals in the exposed population must be take attention. The rate of change in the infected population increase because the population is endemic. The increase in the rate of change in the infected population depend on the number of individuals in the exposed population. And so thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Okay, that is my study about the infectious disease into areas. Maybe there are questions